Hello there, and welcome. Tonight, I want to take you somewhere far away from the noise and the hurry of the day, somewhere beyond the glow of city lights and the ceiling of your room. We're going on a journey to a place of profound silence, a place where time itself seems to slow down, and the only lights are ancient, distant suns. There is no need to pack, no need to prepare. All you need to do is find a comfortable position. Allow your body to feel heavy and relaxed, and let your mind drift along with my voice. Just breathe. A slow, easy breath in, and a long, gentle breath out. Feel the stillness begin to gather around you. That is where we are heading, into the great, peaceful stillness. Tonight, we are venturing into the quiet depths of space. But we're not going as adventurers seeking action, or as scientists demanding answers. We're going as quiet observers, as dreamers, content to simply float and to wonder. We are travelling together, you and I, into a gentle mystery, one that unfolded in our own cosmic neighbourhood not so long ago. It is a story about a visitor from the outer dark, a traveller known to us by the name Three-Eye Atlas. You may have heard of it. It was for a time a faint whisper of promise in the astronomical community, a comet that might have become something spectacular. But our journey tonight is not about what it might have become. It is about what it might have been, all along. We're here to contemplate a simple, gentle question. A question that at first might sound like a story from a forgotten book, or a late-night conversation between friends staring at the stars. The question is this: what if the true nature of Comet Atlas was hidden from the public? Now, when we hear a question like that, our minds can sometimes jump to conclusions. We might imagine secret files and hushed meetings, a grand conspiracy to conceal a profound truth. But that is a story for another time, a story filled with sharp edges and loud alarms. Our journey tonight is softer. The path we will walk is one of quiet wonder, not anxious suspicion. So let us rephrase the question. Let's soften its edges. What if the comet's true nature was hidden, not by any human agency, but by the universe itself? Hidden in plain sight, veiled by our own expectations of what a comet should be. It's a question that acknowledges the limits of our understanding, that honours the possibility that the cosmos is far more strange and far more subtle than we can currently comprehend. It suggests that perhaps the universe does not always shout its secrets, but sometimes, just sometimes, it whispers them. What if this traveller, this faint smudge of light on its long journey toward our sun, was not merely a passive ball of ice and rock? What if its journey, its brief, bright life in our skies, and its eventual quiet disappearance was a message? A story told not in words, but in light, dust, and motion. A story hidden from us only because we have not yet learned the language in which it was written. This is the heart of our journey tonight, to gently peel back the layers of the known and to peer into the beautiful, peaceful unknown that lies just beyond. As we embark on this journey together, drifting through these cosmic questions, I invite you to become a part of this exploration in a deeper way. If you find a sense of peace or wonder in these wanderings, perhaps you might share this quiet space with a friend who also seeks a gentle escape from the noise of the world. Or maybe you could support our continued creation of these voyages by subscribing to our channel. It is through your quiet support that these journeys are made possible, allowing us to drift into even more distant mysteries together. Think of it as adding a little fuel to our ship of dreams so we can continue to explore the silent, starry seas. Now, let us return to the stillness and let our voyage truly begin. Imagine yourself now, floating in a place of perfect blackness. It is not a cold or frightening blackness. It is a warm, velvety dark, like the softest blanket. Below you, if there is a below, is the gentle curve of the earth, a silent, swirling marble of blue and white. It is beautiful from up here, peaceful. The endless chatter of its surface is muted into a single low hum, a planetary lullaby. You are safe, you are weightless, and you are ready to listen. From this vantage point, we can see the solar system not as a series of disconnected planets, but as a single, connected family, all dancing in a slow, gravitational ballet around our star, the Sun. We see the familiar paths of Mercury, Venus, Mars. We see the grand, stately orbits of Jupiter and Saturn with their retinues of moons. And we drift further, past the ice giants, Uranus and Neptune, out into the vast dark frontier of our solar system. It is out here, in the profound and echoing silence, that our story begins. For eons, our visitor drifted in this cold, dark place. A place so far from the sun that our star would look like just another bright point of light in the sky. It was in a state of deep sleep, a frozen relic from the dawn of the solar system, or perhaps from somewhere else entirely. We call these objects comets, a name that comes from the Greek for long-haired, because of the beautiful tails they grow as they approach the sun. For millennia, humanity has watched them, sometimes with fear, often with awe. They were seen as omens, as messengers from the gods, their sudden appearance in the night sky a break from the predictable, comforting rhythm of the stars. And in a way, our ancestors were right. Comets are messengers. They are messengers of time, carrying with them the pristine, untouched material from which our worlds were born. They are time capsules, holding the chemical secrets of an era 4.5 billion years in the past. When we study a comet, we are not just looking at a celestial snowball, we are looking at our own origins. We are reading a chapter from the very first page of our solar system story. Our particular messenger, 3I Atlas, was first spotted in the final days of 2019. It was discovered by a robotic survey system in Hawaii, a tireless automated eye that scans the sky night after night, searching for anything that moves, anything that changes. And on that night, it found something, a tiny faint patch of light, moving slowly against the backdrop of immovable stars. To the automated system, it was just another data point, another entry in a vast catalogue. But to the humans who reviewed the data, it was the first hint of a new visitor. They named it Atlas, after the survey that found it, the Asteroid Terrestrial Impact Last Alert System, a dramatic name designed to find objects that might pose a threat to Earth. But this visitor was no threat. It was on a path that would keep it at a safe distance. Its story was not one of danger, but one of promise. As astronomers watched it night after night, they noticed something exciting. It was getting brighter, and it was getting brighter faster than expected. A comet's brightness is a simple function of its journey. As it falls toward the sun's warmth begins to heat its frozen nucleus. The ice, which is not just water ice but also frozen gases like carbon dioxide and carbon monoxide, begins to turn directly into a gas, a process called sublimation. This gas erupts from the surface, carrying with it dust and debris that has been locked away for billions of years. This cloud of gas and dust is what we call the coma, the fuzzy, glowing atmosphere that surrounds the comet's core. And it is this coma reflecting the light of the distant sun that we see from Earth. The faster a comet brightens, the more active it is. A rapidly brightening comet suggests it has a large nucleus, or that it is rich in these volatile ices that are easily vaporized. And Comet Atlas was brightening very, very quickly. Projections were made, calculations were run. And a quiet excitement began to build. If it continued on this trajectory of brightening, Comet Atlas could become spectacularly bright by the time it made its closest approach to the sun in the spring of 2020. Some whispered it could become visible to the naked eye, a beautiful ghostly streak in our twilight skies. It had the potential to be the comet of a generation. Think of that for a moment. A visitor from the deep dark, silent for billions of years, making a journey of unimaginable distance, arriving in our neighborhood with a promise of putting on a spectacular show for all of humanity to see. It is a romantic notion, a cosmic performance scheduled billions of years in advance. It connects us, in our fleeting lives, to the grand, slow, majestic clockwork of the cosmos. It reminds us that we are part of something so much larger, so much older than our daily concerns. And so, we watched, and we waited. Telescopes, both large and small, professional and amateur, turned their gaze toward this faint incoming messenger. We were ready for the show. We were expecting a familiar story. A comet arrives, it brightens, it grows a magnificent tail, it rounds the sun, and it begins its long, slow journey, back out into the darkness from whence it came, not to be seen again for thousands of years. This is the story of a comet. It is a story we have seen play out time and time again. But what if that wasn't the story this visitor came to tell? What if the show we were anticipating was a misunderstanding, a misinterpretation of the messenger's intent? This is where our gentle question returns, whispering in the quiet between the stars. What if the true spectacle was not the comet's brightness, but its disappearance? What if its purpose was not to shine, but to dissolve? Let's drift with that thought for a moment. Let it settle. We're so often drawn to things that are bright, loud, and clear. We look for definitive signals, for unambiguous events. A bright comet in the sky is just that. It is a clear, undeniable presence, but the universe is rarely so simple. Its most profound truths are often found not in the bright centers of things, but in the subtle shadows at the edges. They're found in the quiet transitions, in the things that fade away, in the signals that are so faint we almost miss them. Our journey tonight will take us into those shadows. We will follow the story of Comet Atlas not just to its peak brightness, but beyond it, into the quiet moments when things started to change. We will explore the gentle fragmentation, the slow, graceful fading of its light. And we will ask ourselves, was this simply the predictable, unceremonious death of a fragile comet, torn apart by the growing warmth of the sun? Or was it something else? Was it a delivery, a deployment, a transformation? These questions do not require us to abandon science. In fact, they invite us to look at the science even more closely, but with a different kind of eye, an eye open to possibility, an eye that is not afraid of mystery. As we drift deeper into the night, we will look at the data, we will look at the images, we will listen to what the astronomers saw, but we will hold it all gently, allowing space for wonder to bloom in the gaps between the facts. For now, just rest in this idea. The idea of a hidden truth, not a truth concealed by men in dark rooms, but a truth concealed by its own subtlety. A truth that was, perhaps, broadcast for all to see, but in a form so alien, so unexpected, that it passed by almost completely unnoticed. A message in a bottle thrown into the cosmic ocean that looked to us like just another piece of driftwood. Imagine the sheer scale of it all, the distance this object travelled, the time it spent in the cold and the dark, the incredible, lonely journey across a void that is almost impossible for the human mind to truly grasp. To think that such a journey would have a purpose beyond simply falling toward a star is not an unscientific thought. It is a deeply human one. It is the same impulse that makes us look up at the stars and see stories, the same impulse that makes us create art and music, the same impulse that drives us to ask why. Our journey tonight is an embrace of that why, a gentle, sleepy exploration of a possibility. We will not find any definitive answers. Answers are often loud, and tonight is about the quiet. Instead, we will find better questions. We will find a deeper appreciation for the mystery, and perhaps, in that mystery, we will find a new sense of our own place in this vast, silent, and wondrously strange universe. So let your breathing slow down even more. Let the darkness behind your eyes become a vast, open space. The story of Comet Atlas is just beginning. We have set the stage. We have met our traveller, we have asked our gentle question. Now, it is time to journey to the place where it was born, to the great cold nursery of comets that lies at the very edge of the sun's influence. It is a place of profound quiet, a place of whispers, and it is there that the first clues to our mystery may be waiting. Let the world outside your window fade away. Let the thoughts of the day dissolve like sugar in water. There is only the gentle darkness, the soft sound of my voice, and the slow, steady rhythm of your own breathing. We are adrift now, adrift on a sea of stars, and there is a story waiting for us, out there in the quiet. Let's go and listen. Consider for a moment the nature of observation itself. When we look at something, we change it. Not in the quantum mechanical sense, though that too is a beautiful mystery for another night, but in the human sense. We bring our expectations, our experiences, our limitations to every act of seeing. When medieval astronomers saw comets, they saw divine messengers, or harbingers of doom. When Enlightenment scientists saw them, they saw clockwork mechanisms obeying Newton's laws. And when we see them today, we see time capsules from the birth of our solar system. Each generation sees what it is prepared to see, what its framework of understanding allows it to perceive. So what might we be missing about Comet Atlas simply because we are not prepared to see it? What assumptions do we carry that might blind us to its true nature? These are not questions meant to undermine science, but to expand it. Science itself teaches us that our understanding is always provisional, always ready to be updated by new evidence, new perspectives, new ways of looking. And sometimes, the most profound discoveries come not from new data, but from looking at old data with fresh eyes. The story of Comet Atlas begins, as all comet stories do, in the deep freeze of the outer solar system. But to understand where it came from, we need to understand the architecture of our cosmic neighborhood. Picture, if you will, the solar system as a vast estate. At the center is the manor house, our sun, warm and bright. Closest to it are the terrestrial planets, the well-manicured gardens where life has taken root on at least one world. Further out are the gas giants, like grand fountains and sculptures, massive and impressive. And then, at the very edges of the estate, beyond the last of the known planets, is the wilderness. This wilderness has a name. We call it the Oort cloud, named after the Dutch astronomer Jan Oort, who first proposed its existence in 1950. It is not a cloud in any earthly sense. It is a sphere, a vast gossamer sphere of icy bodies surrounding our entire solar system. If the orbit of Neptune were the size of a quarter, the Oort cloud would be a sphere 2 football fields across. It is a realm of almost incomprehensible scale and emptiness. The objects within it, these proto-comets, are separated by distances so vast that if you were standing on one, the next nearest might be as far away as Earth is from the Sun. The Oort cloud is a repository of the solar system's most primitive material. These are the leftovers from the solar system's formation, the bits and pieces that never got swept up into planets. They have been out there in the deep cold for over 4 billion years. The temperature is only a few degrees above absolute zero. Time itself seems to barely exist in such a place. Nothing changes, nothing happens. It is a realm of perfect preservation, a cosmic freezer where the ingredients of worlds wait in patient silence. But every now and then something disturbs this ancient peace. Perhaps it is the gravitational tug of a passing star, still distant but massive enough to send ripples through the fabric of space. Perhaps it is the slow, patient influence of the galaxy itself, as our solar system bobs up and down through the galactic plane in its quarter-billion-year orbit around the galactic center. Or perhaps, and here we allow ourselves a moment of wonder, perhaps sometimes the disturbance comes from within. Perhaps some of these objects have been waiting for just the right moment, following a schedule written into their very structure, to begin their long fall toward the light. Whatever the cause, occasionally one of these frozen wanderers is nudged from its distant orbit. Its perfect circle becomes an ellipse, and slowly, ever so slowly, it begins to fall. This is not a fall like a stone dropped from a height. This is a fall that takes millions of years. A fall so slow that entire species can evolve and go extinct during the journey. A fall through emptiness so complete that the falling object might travel for centuries without passing close to anything larger than a grain of dust. This is the journey that Comet Atlas began, perhaps millions of years ago. From the Oort cloud, it would have fallen first through the Kuiper belt, that collection of icy bodies beyond Neptune where Pluto resides. It would have passed through the realm of the gas giants, perhaps having its orbit refined by their gravitational influence. And finally, it would have entered the inner solar system, the realm of warmth and light, where its long frozen surface would begin to respond to the sun's heat. But here is where we might pause and wonder. The journey I have just described assumes that Comet Atlas originated in our Oort cloud. But what if it didn't? What if it was, as its designation suggests, an interstellar object? The I in 3i Atlas stands for interstellar, marking it as potentially the third confirmed object from beyond our solar system to pass through our neighbourhood after Oumuamua and Comet Borisov. If it truly was interstellar, then its journey was not millions but potentially billions of years long. It would have travelled through the empty spaces between stars, through regions where the very concept of up or down loses all meaning, where there is no sun to orbit, no gravity well to call home. Imagine that journey. Imagine drifting through interstellar space for eons, with nothing but the faint light of distant stars for company. The nearest star might be light years away, appearing no brighter than stars appear to us from Earth. You would be truly alone, more alone than anything in our solar system can ever be. And yet, you would be carrying something, a message perhaps, a purpose, a destination programmed into your trajectory billions of years ago. This brings us to one of the most intriguing aspects of our mystery. If Comet Atlas was indeed an interstellar visitor, how did it know where to go? The odds of a random object from interstellar space happening to pass through our inner solar system are astronomically small. Space is so vast, so empty, that such chance encounters should be exceedingly rare. And yet, in the span of just a few years, we have detected 3 such objects. Is this just coincidence? Are we simply getting better at spotting them? Or is there something else at play? Consider this possibility. What if interstellar objects are not random at all? What if they are targeted? What if somewhere out there, in the vast reaches of interstellar space or in distant solar systems we have yet to discover, there exists an intelligence that sends these objects our way? Not as weapons or invasions, but as gentle probes, as messages in bottles cast into the cosmic ocean, designed to wash up on the shores of worlds where someone might be watching. This is not as wild a speculation as it might first appear. We ourselves have done something similar. The Voyager spacecraft, launched in 1977, are now in interstellar space, carrying with them golden records containing sounds and images from Earth. There are messages in bottles, our attempts to communicate with whoever might be out there. If we, a young technological civilization, have already sent objects into interstellar space, why shouldn't we expect that older, more advanced civilizations might have done the same? And if they have, what better disguise for such a probe than a comet? Comets are natural objects. They appear regularly in our skies. We have a framework for understanding them. We expect them. A probe disguised as a comet could enter our solar system, perform its observations and leave without raising any suspicions. It would be hidden in plain sight, camouflaged by our own expectations. But let's pull back from such speculation for a moment and return to what we know. Comet Atlas, whatever its origin, was discovered on December 28, 2019, by the Atlas Survey in Hawaii. The survey consists of 2 telescopes, one on Mauna Loa and one on Haleakala, that scan the sky every clear night, looking for moving objects. They take multiple images of the same patches of sky and then compare them, looking for anything that has changed position. It is patient, methodical work, mostly done by computers, but ultimately requiring human eyes to confirm what the algorithms detect. On that December night, the telescope on Mauna Loa captured something interesting. In a series of images of the constellation Ursa Major, the Big Dipper, there was a faint smudge that moved between frames. It was magnitude 19.6, far too faint to see with the naked eye or even most amateur telescopes. To give you a sense of how faint that is, it was about 400,000 times dimmer than the faintest star visible to the naked eye on a clear dark night. It was just a whisper of light, barely distinguishable from the background noise of the universe. The discovery was reported to the Minor Planet Center, the global clearinghouse for observations of small solar system bodies. It was given the designation C2019Y4, indicating it was the fourth comet discovered in the second half of December 2019. The Atlas team continued to observe it, refining its orbit, and something exciting began to emerge. The comet was on a path that would bring it relatively close to the Sun in May 2020, and it was brightening rapidly. By March 2020, Comet Atlas had brightened by a factor of 4,000. It was now visible in amateur telescopes, and its coma had grown to an impressive size. Some estimates suggested the coma was over 400,000 miles across, roughly half the diameter of the Sun. This was unusual. Most comets don't develop such large comas until they are much closer to the Sun. It suggested that Comet Atlas was either very large or very active, possibly both. The astronomical community began to take serious notice. Papers were written, observations were scheduled on major telescopes. Amateur astronomers around the world turned their instruments toward Ursa Major, hoping to catch a glimpse of what might become a spectacular sight. There was talk that Comet Atlas might become as bright as Venus, visible even in twilight skies. Some even speculated it might be visible during the day, but we should remember that predicting comet brightness is notoriously difficult. Comets are, as astronomer David Levy once said, like cats. They have tails, and they do precisely what they want. They can brighten suddenly and unexpectedly, or they can fizzle out just when you expect them to put on a show. This unpredictability is part of their charm, but it also hints at the complex processes happening within them. A comet's nucleus is not a uniform ball of ice. It is more like a loosely packed snowball, full of voids and variations. Different areas may have different compositions, with some regions rich in volatile ices that sublimate easily, and others made of more refractory materials that resist the sun's heat. As the comet rotates, different regions are exposed to sunlight, leading to variations in activity. Jets of gas and dust can erupt from specific spots, creating fountains that can change the comet's brightness dramatically. Moreover, comets can fragment. The stresses of approaching the sun, the uneven heating, the jets of escaping gas, all of these can cause a comet's nucleus to break apart. When this happens, fresh ice is exposed, leading to a temporary increase in brightness. But it also means the comet is dying, breaking into pieces that will continue to fragment until nothing is left but a stream of dust and gas. This is what began to happen to Comet Atlas in late March 2020. Observers noticed that its nucleus appeared elongated, a sign that it might be breaking apart. By early April, it was clear that the comet was fragmenting. Multiple pieces could be seen in telescope images, drifting slowly apart like a cosmic dandelion seed head, dispersing in a gentle breeze. For those hoping for a spectacular naked-eye comet, this was disappointing news. A fragmenting comet rarely lives up to its early promise. The pieces continue to break apart, the ice sublimates away, and what might have been a brilliant display becomes a faint, diffuse glow that quickly fades from view. By May 2020, when Comet Atlas made its closest approach to the Sun, it was barely visible even in large telescopes. The show was over before it had really begun. But what if the show was never meant for our eyes? What if the fragmentation was not a failure but a function? What if Comet Atlas was designed to break apart, to scatter its contents across the inner solar system like seeds on the wind? This brings us back to our central mystery, our gentle question that whispers in the darkness. Think about how we might send a message to another star system if we had millions of years to plan it. We wouldn't send just one probe, that would be too risky. What if it malfunctioned? What if it missed its target? Instead, we might send a cluster of probes, all travelling together, designed to separate at just the right moment to maximise coverage, to ensure that at least some of them completed their mission. Now imagine these probes are not made of metal and silicon, but of ice and dust, materials that would naturally sublimate and disperse as they approached a star. The very act of delivering the message would destroy the messenger, ensuring that no trace of artificial origin remained. It would be the perfect camouflage, the ultimate implausible deniability. To any observers, it would look exactly like a natural comet breaking apart, something that happens all the time. But what could such a message contain? What information could be encoded in ice and dust? Here we must let our imaginations roam a bit, guided by what we know about the possibilities of advanced technology. Perhaps the dust grains themselves are the message, each one a tiny capsule containing information at the molecular or even atomic level. Perhaps the pattern of fragmentation, the way the pieces separated and dispersed, was itself a kind of writing, a story told in trajectories and timing. Or perhaps, and this is where we venture into the realm of the truly speculative, perhaps the message was not in the comet itself, but in what it left behind. As Comet Atlas fragmented and sublimated, it released vast amounts of dust and gas into the inner solar system. This material doesn't just disappear, it continues to orbit the Sun, spreading out along the comet's path. Earth, in its annual journey around the Sun, will eventually pass through this debris stream. When it does, some of that material will enter our atmosphere, creating meteor showers, those brief streaks of light we sometimes call falling stars. But what if some of that material is more than just dust? What if hidden among the natural particles are artificial ones, designed to survive the plunge through our atmosphere and reach the surface? These wouldn't be large, obvious artifacts. They might be microscopic, indistinguishable from natural cosmic dust except at the molecular level. They might be designed to interact with our environment in subtle ways, perhaps even with life itself. This is not an entirely unprecedented idea. We know that Earth is constantly bombarded by material from space. Tons of cosmic dust fall to Earth every day. We know that some of this material contains organic molecules, the building blocks of life. Some scientists have even suggested that life on Earth might have been seeded by such cosmic deliveries, a hypothesis called panspermia. If life can travel between worlds naturally, why not artificially? But let's not get too far ahead of ourselves. These are possibilities, not certainties. They are whispers in the dark, not shouts in the light. The beauty of our mystery is not in solving it definitively, but in contemplating it gently, in allowing it to expand our sense of what might be possible. As we continue our journey through this cosmic mystery, let's take a moment to appreciate the sheer elegance of the possibility we're considering. If Comet Atlas was indeed some form of messenger, its design would represent a masterpiece of cosmic engineering. It would have to survive millions or billions of years in the cold of space. It would have to navigate accurately across vast distances. It would have to activate at just the right time, in just the right way, and it would have to do all of this while appearing completely natural. This is engineering on a scale and time frame that challenges our imagination. We build things to last decades, maybe centuries if we're ambitious, but millions of years, billions. That requires a completely different way of thinking about design and purpose. It requires patience on a cosmic scale, planning for contingencies that won't arise for eons, and acceptance that the beings who launch the mission would never see its completion, unless, of course, they planned for that too. What if the builders of such a messenger were not limited by biological lifespans? What if they were artificial intelligences, or post-biological beings who had transcended the limitations of flesh and blood? Or what if they simply had a different relationship with time than we do, viewing millions of years the way we view decades? These questions take us to the very edge of what we can meaningfully contemplate. They remind us that the universe is not just vast in space, but vast in time, and potentially vast in the forms of intelligence it might contain. Our human perspective, rooted in our brief lives and our single planet, is like trying to understand the ocean from a single drop of water. Yet that single drop contains the essence of the ocean. We are part of the universe, made of the same stuff as stars and comets. The atoms in our bodies were forged in the hearts of dying stars, scattered across space and eventually assembled into the complex patterns we call life. In a very real sense, we are the universe trying to understand itself. And perhaps, just perhaps, we're not the only ones engaged in this cosmic contemplation. The story of Comet Atlas takes us now to the realm of the Oort cloud, that vast sphere of icy bodies that surrounds our solar system like a gossamer cocoon. To understand our mysterious visitor, we must understand the place from which it might have come, or at least the place it passed through on its long journey to our neighbourhood. The Oort cloud is more than just a repository of comets. It is a boundary, a transition zone between the solar system and interstellar space. It is where our sun's influence fades to a whisper, where the gravitational symphony of our star gives way to the vast silence of the galactic void. Picture yourself drifting outward from the sun, past all the planets, past the Kuiper belt where Pluto resides. You've been travelling for years, decades, centuries. The sun has shrunk to just another star, perhaps a bit brighter than the others, but no longer the dominant presence it is in the inner solar system. You're now entering the realm of the Oort cloud, though you wouldn't know it by looking around. There are no signposts, no visible boundaries. The space around you looks empty, as it has for most of your journey. But you have entered a different kind of emptiness, one pregnant with possibility. The Oort cloud begins roughly 2,000 astronomical units from the Sun. An astronomical unit, or AU, is the distance from Earth to the Sun, about 93 million miles. So we're talking about a distance of 186 billion miles, or about 0.33 light years. But this is just the inner edge. The Oort cloud is thought to extend out to perhaps 100,000 AU, or about 1.5 light years from the Sun. At that distance, our Sun's gravity is so weak that it can barely hold onto objects. The slightest perturbation can send them tumbling into interstellar space or falling toward the inner solar system. Within this vast sphere, scientists estimate there may be trillions of icy bodies, ranging in size from mountains to small moons. Yet the space is so vast that if you were standing on one of these objects, the nearest neighbour might be millions of miles away, invisible even with a telescope. It is a lonely place. A place where solitude is not just a state of mind, but a physical reality. The objects in the Oort cloud are thought to be composed primarily of water ice, methane ice, and ammonia ice mixed with rocky material. They are the leftover building blocks of the solar system, pieces that were ejected from the inner regions during the chaotic early days of planetary formation. For over 4 billion years they have been out there, circling in the dark, preserved in a deep freeze that makes Antarctica look tropical by comparison. The temperature in the Oort cloud hovers just a few degrees above absolute zero, the theoretical temperature at which all molecular motion stops. At such temperatures, chemical reactions essentially cease. Time, in a chemical sense, almost stops. An object in the Oort cloud is like an insect trapped in amber, perfectly preserved, waiting. But waiting for what? In the traditional view, these objects wait for a gravitational nudge, a random perturbation that sends them falling toward the Sun. This could be caused by a passing star, the gravitational tide of the galaxy, or even the hypothetical Planet 9 that some astronomers believe lurks in the outer solar system. Once nudged, the object begins its long fall, a journey that can take millions of years. As it approaches the Sun, it heats up, develops a coma and tail, and becomes what we call a comet. But what if some of these objects are waiting for something else? What if they are waiting for a signal, a specific set of conditions, a particular alignment of planets? What if they are not passive snowballs but patient sentinels, placed there eons ago by intelligences we can barely imagine? Consider the strategic value of the Oort cloud for an advanced civilization wanting to monitor or communicate with inner solar systems. It is far enough out to avoid detection, yet close enough to reach the inner planets within a reasonable time frame. Objects placed there could remain dormant for billions of years, activating only when certain conditions are met. They would be virtually undetectable until they began their inward journey, and even then, they would appear to be natural comets. The Oort cloud is also a perfect location for a relay station, a waypoint for interstellar travelers or messages. If you were crossing the vast distances between stars, the Oort clouds of various solar systems would be like islands in an endless ocean, places to pause, refuel, or redirect your journey. They might be seeded with resources, information, or even dormant technology, waiting for the right visitor to activate them. This is all speculation, of course, but it is speculation grounded in logic. We humans have only been a technological species for a few hundred years, and already we're thinking about interstellar travel and communication. We have sent probes to the outer planets and beyond. We have imagined generation ships and light sails and fusion rockets. Given millions or billions of years of technological development, what might we achieve? And if we could achieve it, why shouldn't other civilizations have done so already? The Fermi paradox, named after physicist Enrico Fermi, asks a simple question. If the universe is so vast and so old, and if life is not unique to Earth, then where is everybody? Why haven't we detected signs of other civilizations? There are many proposed answers to this paradox, ranging from the pessimistic, civilizations destroy themselves, to the optimistic, they are out there but choosing not to contact us yet. But one intriguing possibility is that they are here, have been here, but in forms we don't recognize. What if the solar system is full of artifacts and messages from other civilizations, but we simply don't know how to see them? What if some of the objects we classify as natural are actually artificial? What if the distinction between natural and artificial becomes meaningless at a certain level of technology? A sufficiently advanced civilization might build things that are indistinguishable from natural objects, either by design or simply because that is the most efficient way to build them. Comet Atlas in this context becomes a test case for our ability to recognize the potentially artificial. Its behavior was unusual in several ways. It brightened faster than expected. It developed an unusually large coma for its distance from the Sun. It fragmented in a peculiar pattern. None of these things prove it was artificial, but they do raise questions. They invite us to look more closely, to consider possibilities beyond the conventional. Let's delve deeper into the nature of the Oort cloud and what it might tell us about Comet Atlas. The cloud is not uniform. It has structure. There is thought to be an inner Oort cloud, sometimes called the Hills cloud, which is more disk-like and aligned with the plane of the solar system. Then there is the outer Oort cloud, which is more spherical. The transition between these regions is gradual, and objects can migrate from one to the other over time. If Comet Atlas originated in the Oort cloud, which part did it come from? Its orbit suggests it came from the outer regions, the spherical part that extends far into space. This is significant because objects from the outer Oort cloud are more likely to have been perturbed by external forces, such as passing stars or the galactic tide. They're also more likely to have interacted with interstellar space, perhaps capturing material or information from beyond our solar system. But there's another possibility. What if Comet Atlas didn't originate in our Oort cloud at all? What if it came from the Oort cloud of another star? As stars move through the galaxy, they occasionally pass close to each other. Not close enough to disrupt their planetary systems, but close enough for their Oort clouds to interact. Objects can be exchanged between stars during these encounters, cosmic messengers passed from one system to another. Our Sun has likely had many such encounters over its 4.6 billion year lifetime. The star Gliese 710, for example, is currently heading our way and will pass within about 0.16 light years of the Sun in about 1.3 million years. That's well within the Oort cloud. Such an encounter will likely send a shower of comets into the inner solar system, but it will also provide an opportunity for exchange for objects from our Oort cloud to be captured by Gliese 710 and vice versa. If civilizations exist around other stars, these Oort cloud exchanges could be a natural method of interstellar communication or even travel. Instead of launching missions across the vast distances between stars, you could simply place your messages or probes in your own Oort cloud and wait for a close stellar encounter to deliver them. It would be slow, taking millions of years, but it would require no propulsion, no energy expenditure beyond the initial placement. It would be the ultimate in patient low-energy communication. This brings us to an intriguing thought. If Oort cloud exchanges are common, and if other civilizations have had the same idea, then our Oort cloud might contain objects from many different star systems, accumulated over billions of years. It could be a cosmic library, a repository of messages and artifacts from across the galaxy. Most of these objects would remain in the outer darkness, never venturing into the inner solar system where we could detect them. But occasionally one might be nudged inward, beginning the long fall toward the Sun. Could Comet Atlas have been one of these ancient messengers? Could it have been waiting in our Oort cloud for millions of years, placed there during a close stellar encounter long before humans evolved? Or could it have been a more recent arrival, inserted into our solar system by a passing star within the last few million years? The timing of its arrival is intriguing. It appeared just as humanity was developing the technology to study it in detail. We had automated sky surveys to detect it, sophisticated telescopes to observe it, and spectrographs to analyze its composition. We had the internet to share information about it globally in real time. If it was a messenger, it arrived at the perfect moment for us to receive its message, even if we didn't fully understand it. But perhaps understanding is not required. Perhaps the message is in the encounter itself, in the fact that we noticed, observed, and wondered. Perhaps the purpose was simply to make us think, to expand our conception of what is possible, to prepare us for future revelations. Like a teacher who asks questions not to get answers but to stimulate thought, perhaps Comet Atlas was meant to make us question our assumptions about the universe and our place in it. As we contemplate these possibilities, let's not lose sight of the beauty and wonder of the Oort cloud itself, regardless of whether it harbours artificial objects. It is a realm of profound silence and stillness, a place where time seems to hold its breath. It is the boundary between our cozy solar system and the vast wilderness of interstellar space. It is a reminder of how small and precious our inner solar system is, a tiny bubble of warmth and light in an ocean of cold and darkness. The Oort cloud also connects us to the deep history of our solar system. The objects within it are fossils, preserved remnants of the protoplanetary disk from which our planets formed. When we study a comet from the Oort cloud, we are looking at material that has been essentially unchanged since before Earth existed. We are touching the raw ingredients from which worlds are made. This is humbling and inspiring in equal measure. It reminds us that we are newcomers to a very old story. Earth has existed for 4.5 billion years, but complex life has only been around for about 600 million years. Humans have existed for perhaps 300,000 years, and our recorded history spans only about 5,000 years. We are a blink of an eye in cosmic terms, a single note in a symphony that has been playing for eons. Yet in that brief time, we have developed the ability to look outward, to study comets and planets and stars. We have developed the capacity for wonder, for curiosity, for contemplation of our place in the universe. We have become, in a sense, the universe's way of knowing itself. And perhaps we're not alone in this role. Perhaps throughout the galaxy, on worlds we have yet to discover, other beings are also looking up at their night skies, watching comets pass and wondering about their origins and meanings. The Oort cloud, in this view, becomes not just a collection of icy bodies, but a bridge between worlds, a common feature that all star systems might share. Just as all beaches have sand and all forests have trees, all star systems might have Oort clouds, and these clouds might serve similar functions across the galaxy. They might be the natural infrastructure for a galactic community we have yet to join, a network of nodes through which information, and perhaps even life itself, flows. As we drift deeper into our contemplation of Comet Atlas and its possible origins, we find ourselves at the intersection of science and philosophy, fact and speculation. We're exploring not just what is, but what might be. We're using our imagination not to escape reality, but to expand it, to consider possibilities that lie just beyond the edge of our current understanding. This is the gift that objects like Comet Atlas give us. They remind us that the universe is full of mysteries, that our knowledge, vast as it may seem, is still limited. They invite us to remain curious, to keep looking up, to never lose our sense of wonder. Whether Comet Atlas was a natural comet or something more, its visit to our skies was a reminder of our connection to the cosmos, our participation in a story much larger than ourselves. Now, as we prepare to delve even deeper into the nature of comets themselves, let's carry with us this sense of cosmic perspective. Let's remember that we're exploring not just chunks of ice and rock, but messengers from the depths of time and space. They carry with them stories of the solar system's birth, and perhaps, just perhaps, messages from minds that have contemplated the same stars we see, asked the same questions we ask, and wondered, as we wonder, about their place in the vast, beautiful, mysterious universe. The journey from the Oort cloud to the inner solar system is not a simple fall. It is a complex dance of gravitational forces, a slow spiral that can take millions of years. As an object like Comet Atlas begins its journey, it is essentially invisible, too small and too distant to detect with our current technology. It moves slowly at first, its velocity measured in meters per second rather than kilometers. But as it falls deeper into the sun's gravitational well, it accelerates, trading gravitational potential energy for kinetic energy, following the same laws that govern all motion in the universe. This journey is lonely beyond human comprehension. For most of it, the comet is in complete darkness. The sun is just another star, perhaps slightly brighter than the others, but providing no warmth, no light sufficient to read by. No indication that it is special in any way. The comet tumbles slowly through this darkness, rotating perhaps once every few hours or days, each rotation bringing the same view of distant, unchanging stars. But as the comet crosses the orbit of Neptune, things begin to change. The sun is now noticeably brighter than other stars. It has become a distinct disk rather than a point of light, and most importantly, its warmth, feeble as it still is, begins to have an effect. The surface of the comet, which has been at nearly absolute zero for millions of years, begins to warm. Not much at first, perhaps rising from 10 Kelvin to 20 Kelvin, still far colder than anything on Earth. But this tiny increase in temperature is enough to begin sublimating the most volatile ices. This is the beginning of the comet's transformation, from an inert object to an active one. It is like watching a seed begin to germinate after a long winter, or a butterfly emerge from its chrysalis. The comet is awakening, and with that awakening comes the possibility of observation, of discovery, of wonder. As we continue our exploration of Comet Atlas, we turn our attention now to the nature of comets themselves, these ancient storytellers of the cosmos. To understand what made Atlas special, what made it potentially more than just another comet, we must first understand what comets are in their most fundamental sense. They are not merely dirty snowballs as they are often described. They are complex, dynamic objects that bridge the gap between the primordial past and the present, between the frozen outer reaches of our solar system and the warm inner regions where life has flourished. Comets have been part of human consciousness for as long as we have looked up at the night sky. Ancient Chinese astronomers called them broom stars for their sweeping tails. The word comet itself comes from the Greek kometes, meaning long-haired, a poetic description that captures their ethereal appearance. Throughout history, they have been seen as omens, both good and bad, their unexpected appearances disrupting the predictable patterns of the heavens. But beyond their cultural significance, comets are scientifically precious. They are among the most primitive objects in our solar system, preserving in their icy matrices the conditions that existed when the sun was young and planets were just beginning to form. When we study a comet, we are essentially conducting archaeology on a cosmic scale, digging into the deep past of our solar neighbourhood. The nucleus of a comet, its solid core, is typically only a few kilometres across, though some can be much larger. Comet Hale-Bopp, which graced our skies in 1997, had a nucleus estimated at 40 to 80 kilometres in diameter. But size isn't everything with comets. Even a small nucleus can produce a spectacular display if it is rich in volatile materials that sublimate easily in the sun's heat. These nuclei are not uniform spheres of ice. They're irregular, often elongated or bilobed, resembling potatoes or peanuts more than balls. The surface is typically very dark, darker than charcoal, covered with a crust of organic materials that have been processed by billions of years of cosmic radiation. Beneath this dark crust lies the ice, not just water ice, but also frozen carbon dioxide, carbon monoxide, methane, ammonia, and a host of other compounds that would be gases at Earth's temperature and pressure. When sunlight hits this surface, it doesn't heat it uniformly. The dark areas absorb more heat than the lighter areas. Cracks and crevices create hot spots. As the comet rotates, different areas are exposed to sunlight, creating a complex pattern of heating and cooling. This uneven heating drives the comet's activity, creating jets of gas and dust that erupt from specific locations on the surface. These jets are not gentle exhalations. They can be violent eruptions, powerful enough to change the comet's rotation rate or even its orbit slightly. The gas escapes at speeds of hundreds of meters per second, carrying with it dust particles that have been locked in the ice for billions of years. This dust, once released, follows its own orbit around the sun, gradually spreading out along the comet's path to create meteor streams that Earth may encounter years or centuries later. The gas and dust ejected from the nucleus form the coma, the fuzzy atmosphere that surrounds the comet's core. The coma can be enormous, sometimes larger than Jupiter, even though the nucleus producing it might be only a few kilometres across. It's a bit like a small candle creating a room-filling glow, except the room in this case is hundreds of thousands of kilometres across. The coma is not static. It is a dynamic, ever-changing envelope of gas and dust, shaped by the solar wind and radiation pressure from the sun. The solar wind, a stream of charged particles flowing outward from the sun at hundreds of kilometers per second, pushes the lighter gas molecules away from the sun, creating the comet's ion tail. This tail always points away from the sun, regardless of the direction the comet is moving, like a windsock in a cosmic breeze. Meanwhile, the dust particles, being heavier, are less affected by the solar wind but are still pushed by radiation pressure. They form a separate dust tail, often curved as the particles follow their own orbital paths around the sun. Sometimes these two tails are clearly visible as separate structures, one straight and bluish, the ion tail, the other curved and yellowish, the dust tail, reflecting sunlight. This is the classical picture of a comet, the one we learn in textbooks and see in photographs. But Comet Atlas challenged this picture in subtle ways. Its behaviour suggested there might be more to the story, layers of complexity we had not fully appreciated. For one thing, Atlas brightened much faster than most comets. When it was first discovered in December 2019, it was incredibly faint, about magnitude 19.6. By March 2020, it had brightened to magnitude 8, an increase of over 4,000 times in brightness. This rapid brightening suggested either that Atlas had a very large nucleus, or that it was unusually rich in volatile materials, or perhaps that something else was happening, something not accounted for in our standard models. The size of Atlas's coma was also remarkable. By late March 2020, the coma was estimated to be about 720,000 kilometers across, roughly half the diameter of the Sun. This is enormous for a comet still relatively far from the Sun. It suggested that Atlas was releasing vast amounts of material, far more than a typical comet of its size should produce. But then came the fragmentation. In late March and early April 2020, observers noticed that the nucleus of Atlas appeared elongated in telescope images. This was the first sign that the comet was breaking apart. By April 11th, the Hubble Space Telescope confirmed that the nucleus had fragmented into multiple pieces, perhaps as many as 30 fragments, each surrounded by its own small coma. Comet fragmentation is not unusual. The stresses of approaching the Sun can tear a comet apart, especially if it has structural weaknesses or if it is rotating rapidly. Comet Shoemaker-Levy 9 famously fragmented into multiple pieces before crashing into Jupiter in 1994. Comet Linear broke apart in 2000. Comet Elenin disintegrated in 2011. It's a natural process, the cosmic equivalent of an ice sculpture melting in the Sun. But the way Atlas fragmented was interesting. The pieces didn't just break off randomly. They seemed to separate in a controlled manner, drifting apart slowly and maintaining similar brightness for a time. It was almost as if the comet was designed to come apart, each fragment following a predetermined trajectory. This brings us back to our central mystery. What if the fragmentation of Atlas was not a failure but a feature? What if the comet was meant to break apart at just the right distance from the Sun, dispersing its contents across the inner solar system in a specific pattern? Consider how we might design a probe to study multiple planets or moons in a single mission. We might create a carrier spacecraft that releases smaller probes at different points in its journey, each probe targeted at a different destination. The carrier would appear to break apart, but this would be intentional, a planned dispersal rather than a random fragmentation. Now imagine applying this concept to a comet. The main nucleus could be a carrier, containing multiple smaller objects designed to separate at a specific point. These objects could be targeted at different planets or regions of the solar system. To any observer, it would look like natural fragmentation, but it would actually be a sophisticated deployment system. The fragments of Atlas continued to fade and disperse through April and May 2020. By the time of its closest approach to the Sun on May 31st, it was barely visible even in large telescopes. The Great Comet that wasn't, as some disappointed observers called it. But perhaps that misses the point. Perhaps Atlas accomplished exactly what it was meant to accomplish. Think about the dust and gas released by Atlas during its fragmentation. This material didn't disappear. It continued to orbit the Sun, spreading out along Atlas's orbital path. Over time, this material will disperse throughout the inner solar system. Some of it will be swept up by planets, some will fall into the Sun, some will be blown out of the solar system by the solar wind. But for years, perhaps decades, traces of Atlas will remain in our cosmic neighborhood. If Atlas carried a message or a cargo, this dispersal would be an effective delivery mechanism. Instead of a single impact on a single world, you would have a gradual gentle rain of material across multiple worlds. Earth, Mars, Venus, and even the Moon would all receive a share. It would be like seeding a garden, scattering the seeds widely to ensure that some take root. But what kind of message could be carried in comet dust? Here we must venture into the realm of informed speculation, guided by our understanding of chemistry, biology, and information theory. At the simplest level, the dust could carry chemical signatures, unusual isotope ratios or molecular structures that would stand out as artificial to anyone who analysed them carefully. These could be markers saying simply, "We were here, we exist, you're not alone." At a more complex level, The dust could carry organic molecules, perhaps even engineered molecules designed to interact with existing life in specific ways. We know that comets naturally carry amino acids and other organic compounds. What if some comets carry more than that? What if they carry the building blocks not just of life, but of specific kinds of life, designed to thrive in specific environments? This is not as far-fetched as it might sound. We know that some organisms on Earth can survive in space. Tardigrades, those microscopic water bears, have survived exposure to the vacuum of space. Certain bacteria can withstand extreme radiation and temperature variations. If life on Earth can be that hardy, imagine what might be possible with deliberate engineering. But perhaps we're thinking too conventionally. Perhaps the message isn't chemical or biological at all. Perhaps it's physical, encoded in the structure of the dust grains themselves. At the nanoscale, it's possible to create structures that store vast amounts of information. A single dust grain could, in principle, contain libraries of data, waiting to be read by anyone with the technology to do so. Or perhaps the message is even more subtle. Perhaps it's in the pattern of the dispersal, the timing of the fragmentation, the specific elements and isotopes released. Like a cosmic symphony, the message might only make sense when all the parts are considered together, when the full performance is appreciated rather than individual notes. As we contemplate these possibilities, it's important to remember that we're not claiming Atlas was definitely artificial. We're simply exploring the possibility, following the what-if to see where it leads. This is how science progresses, not just through observation and experiment, but through imagination and speculation. Every great discovery began with someone asking, what if things are not as they seem? The study of comets has always been about more than just the comets themselves. It's about understanding our place in the solar system, our connection to the cosmos, our origins, and possibly our future. Comets may have delivered water to the early Earth, making our oceans possible. They may have delivered organic molecules, providing the raw materials for life. They have certainly delivered wonder, inspiring generations of humans to look up and question. Comet Atlas, whether natural or artificial, was part of this grand tradition. It reminded us that the universe still holds surprises, that our knowledge is incomplete, that there is still so much to discover. It invited us to think beyond the conventional, to consider possibilities that might seem like science fiction, but could be science fact. As we watch other comets grace our skies in the years to come, perhaps we'll look at them differently. Perhaps we'll see them not just as visitors from the outer solar system, but as potential messengers from even farther away. Perhaps we'll analyze their composition more carefully, looking for anomalies that might hint at artificial origin. Perhaps we'll track their fragments more diligently, considering the possibility that the dispersal pattern might itself be meaningful. This shift in perspective, this openness to unconventional possibilities, is perhaps the greatest gift that Comet Atlas could give us. It's not about proving that Atlas was artificial. It's about recognizing that the universe might be stranger, more interesting, and more connected than we currently imagine. It's about maintaining a sense of wonder in an age when it sometimes seems like all the great mysteries have been solved. They haven't been solved, not even close. We don't know what dark matter is. We don't know what dark energy is. We don't know how life began. We don't know if we're alone in the universe. These are profound mysteries that may take centuries to unravel, if they can be unraveled at all. And in the meantime, objects like Comet Atlas remind us that even seemingly simple things, like a comet approaching the sun, can hold depths of mystery we've barely begun to plumb. The story of comets is also the story of human curiosity and ingenuity. From ancient astronomers tracking their paths with naked eyes to modern scientists analysing their composition with spectrographs, we have always been drawn to these celestial wanderers. They challenge us to improve our instruments, refine our theories, and expand our understanding. The discovery and observation of Comet Atlas was a testament to how far we've come. The Atlas survey that discovered it uses sophisticated software to analyse thousands of images each night, automatically detecting objects that move against the background stars. Amateur astronomers around the world were able to track its progress using equipment that would have been the envy of professional observatories just a few decades ago. Space telescopes like Hubble were able to image its fragmentation in exquisite detail, yet for all our technological prowess, Atlas reminded us of our limitations. We couldn't predict accurately how bright it would become. We couldn't prevent its fragmentation. We couldn't even agree on exactly why it fell apart when it did. It was a humbling reminder that nature, or perhaps something more than nature, still holds cards we can't see. This humility is valuable. It keeps us curious, keeps us searching, keeps us open to new ideas and possibilities. The moment we think we understand everything is the moment we stop learning. Comet Atlas, in its brief, bright life and quiet death, taught us that there is always more to learn, always another layer of mystery to uncover. As we move forward in our exploration of Atlas and its implications, let's pause for a moment to appreciate the sheer poetry of comets. They are transient beauty incarnate, appearing suddenly, shining briefly, and then fading away. They are reminders of impermanence, yet also of continuity, as they follow orbits that bring them back again and again over millennia. They are simultaneously alien and familiar, made of the same elements as Earth, but arranged in ways that exist nowhere on our planet. In many ways, comets are like thoughts or dreams, appearing from the darkness of the unconscious, brightening as they approach consciousness, and then dissolving back into the depths from which they came. They leave traces, memories, influences that persist long after the original appearance has faded. Just as a powerful dream can shape our waking thoughts for days or years afterward, a comet's visit can influence a civilization's mythology, science, and sense of place in the universe for generations. Comet Atlas was such a visitor, such a dream. It appeared at a time when the world was grappling with a pandemic, when humanity was reminded of its fragility and interconnectedness. While we were focused on a virus too small to see, Atlas reminded us of scales too large to comprehend. While we were confined to our homes, Atlas was crossing billions of kilometers of space. It was a cosmic counterpoint to our earthly concerns, a reminder that the universe continues its ancient patterns regardless of human affairs. Yet Atlas was also intimately connected to human affairs. Its discovery was only possible because humans built telescopes and wrote software, and stayed up night after night searching the sky. Its observation united people across the globe as amateur and professional astronomers shared data, images, and excitement. Its story was told in dozens of languages on hundreds of websites, becoming part of our collective human narrative. This is what comets do. They connect us to each other and to the cosmos. They remind us that we're all riding the same small planet around the same star, sharing the same sky, wondering at the same mysteries. Whether Atlas was natural or artificial, whether it was a simple comet or something more, it succeeded in this fundamental mission. It made us look up. It made us wonder. It made us, for a brief moment, a little more aware of our place in the vast, beautiful, mysterious universe. As we continue to follow the story of Atlas, to trace its journey from discovery to dissolution, we're also tracing our own journey of understanding. We're learning not just about a comet, but about how we think about comets, how we think about the universe, how we think about possibilities that lie just beyond the edge of the known. This meta-learning, this growth in how we approach mystery itself, may be the most valuable outcome of all. The fragments of Atlas have now dispersed, becoming part of the zodiacal cloud of dust that fills the inner solar system. In a sense, Atlas has become part of us, as Earth sweeps up tons of cosmic dust every day. Atoms that were once part of Atlas may now be part of our atmosphere, our oceans, even our bodies. We are, in a very literal sense, made of comet stuff, just as we're made of star stuff. This material connection between comets and Earth is not just poetic, but practical. Some scientists believe that much of Earth's water came from comets, delivered during the heavy bombardment period early in our planet's history. Others suggest that comets may have delivered the organic molecules that became the building blocks of life. If these theories are correct, then we owe our very existence to comets, these wandering ice mountains that occasionally grace our skies. But even if comets didn't deliver water or organics to Earth, they have delivered something equally valuable: perspective. Every comet we observe teaches us something about the solar system's history, about the processes that shape worlds, about the delicate balance of forces that allows a planet like Earth to exist. They are teachers, each one offering lessons for those willing to learn. Comet Atlas offered many lessons. It taught us about the unpredictability of comets, the difficulty of forecasting their behavior. It taught us about fragmentation processes, about how a seemingly solid object can come apart under stress. It taught us about the power of citizen science, as amateur astronomers contributed valuable observations. And perhaps if we are willing to consider unconventional possibilities, it taught us to look more carefully at what we think we know, to question our assumptions, to remain open to mystery. As we turn our attention now to the specific story of our visitor, we must journey back to that December night in 2019 when everything began. The Atlas telescope on Mauna Loa in Hawaii was conducting its routine survey of the sky, its electronic eye patiently scanning sector after sector, taking multiple exposures of each region of sky, comparing them, looking for anything that moved. This is the unglamorous reality of modern astronomy. Not lone observers peering through eyepieces on cold mountaintops, but computers processing thousands of images, algorithms sifting through millions of data points, searching for the telltale signs of motion against the fixed backdrop of stars. On December 28, 2019, the system flagged something interesting in the constellation Ursa Major. It was faint, incredibly faint, just a whisper of light that had shifted position between exposures. The automated system assigned it a temporary designation and flagged it for human review. When astronomers examined the images the next day, they saw what the computer had found: a new comet, so faint it was barely distinguishable from the background noise of the universe, but definitely there, definitely real, definitely moving. The discovery was reported to the Minor Planet Center, the global clearinghouse for observations of small solar system bodies. Other observatories were alerted. Over the following nights, additional observations were made, refining the object's position and motion. Slowly, an orbit began to emerge from the data. The comet was still far from the Sun, out beyond the orbit of Mars, falling inward on a path that would bring it to perihelion, its closest approach to the Sun, on May 30th, 2020. Initial calculations suggested this was a long-period comet, taking approximately 6,000 years to complete one orbit around the Sun. This meant the last time it had visited the inner solar system, if it had visited before, was around 4000 BCE, when humans were just developing writing, when the pyramids of Egypt were still far in the future. It was a visitor from deep time, carrying with it the memory of a younger solar system, a younger Earth, a younger humanity. But there was something unusual about this comet from the very beginning. As astronomers continued to observe it through January and February 2020, they noticed it was brightening faster than expected. Much faster. Comets typically brighten as they approach the Sun following a predictable pattern, their increase in brightness corresponding to their decreasing distance from our star. But Atlas was exceeding all predictions. It was brightening as if it were much larger than the initial estimates suggested, or as if it were made of unusually volatile materials that were sublimating more readily than normal cometary ice. By early March 2020, the excitement in the astronomical community was palpable. If Atlas continued brightening at its current rate, it could become a naked-eye object by May, possibly even visible in twilight. Some optimistic predictions suggested it might rival Venus in brightness, becoming one of the most spectacular comets in decades. The media began to take notice. Articles appeared with headlines about the comet of a generation that was approaching. amateur astronomers dusted off their telescopes and began making plans for observation and photography. But even as the excitement built, there were whispers of concern among some observers. The rapid brightening was almost too good to be true. Comets that brighten too quickly often disappoint, either because they exhaust their volatile materials early, or because the rapid outgassing causes them to fragment. It was as if Atlas was burning too bright, too fast, like a candle with its wick turned up too high. The coma of Atlas was also unusual. By mid-March it had grown to enormous proportions, spanning more than 720,000 kilometers in diameter. To put this in perspective, you could fit more than 50 Earths side by side within Atlas's coma. This vast cloud of gas and dust was being generated by a nucleus that was probably only a few kilometers across, maybe 10 or 20 at most. It was like a tiny seed producing an enormous flower, a disproportion that suggested intense activity within the comet's core. Spectroscopic observations revealed the composition of the coma. Water vapor, as expected, but also carbon monoxide, diatomic carbon, and other molecules. The green tinge visible in photographs came from diatomic carbon molecules fluorescing in sunlight. This is common in comets, but the intensity of the emission from Atlas was notable. It was as if the comet was not just sublimating, but actively decomposing, breaking down at a molecular level. Then came the first signs of trouble. On April 2, 2020, amateur astronomer José de Queiroz in Brazil reported that Atlas appeared elongated in his telescope images. This elongation could mean only one thing: the nucleus was beginning to break apart. Over the following days, other observers confirmed the elongation. The nucleus was definitely changing shape, stretching out, developing multiple brightness centers. On April 11th, the Hubble Space Telescope turned its powerful eye toward Atlas. The images it captured were both beautiful and heartbreaking for those hoping for a great comet. The nucleus had indeed fragmented, broken into multiple pieces, each surrounded by its own small coma. Initial counts suggested at least 4 major fragments, but as observations continued, the count rose. 10 fragments, 20, perhaps as many as 30, all drifting slowly apart like seeds from a cosmic dandelion. The fragmentation of Atlas was not violent or sudden. It was a slow, graceful dissolution, almost peaceful in its progression. The fragments didn't fly apart as if from an explosion. They drifted apart gently, maintaining similar velocities, similar brightnesses, at least initially. It was as if the comet was carefully unpacking itself, revealing contents that had been hidden within its icy matrix for millennia. Each fragment continued to sublimate, producing its own jets of gas and dust. In the Hubble images, these jets were visible as delicate streamers extending from each fragment, creating a complex pattern of overlapping clouds and trails. It was beautiful in the way that decay can be beautiful, like autumn leaves falling from a tree or waves eroding a sandcastle. There was a poetry to the destruction, a grace to the dissolution. But why did Atlas fragment? This is where our mystery deepens. Comet fragmentation is not unusual, but the timing and manner of Atlas's breakup were noteworthy. It began to fragment when it was still about 1.5 astronomical units from the Sun, roughly the distance of Mars's orbit. This is relatively far from the Sun for a comet to experience enough stress to break apart. The solar heating at that distance, while significant, shouldn't have been enough to tear apart a healthy comet nucleus. One possibility is that Atlas was never healthy to begin with. Perhaps it was a rubble pile, a loose aggregation of smaller bodies held together by weak forces. Such an object would be fragile, prone to breaking apart under even modest stress. The increasing solar heating and the jets of gas from sublimation could have been enough to overcome the weak gravitational and chemical bonds holding it together. Another possibility is that Atlas was rotating too quickly. As a comet sublimates, the jets of gas can act like tiny rockets, gradually spinning up the nucleus. If the rotation becomes too fast, centrifugal forces can overcome gravity, causing the comet to fly apart. This has been observed in other comets, though usually closer to the Sun where the outgassing is more intense. But there's a third possibility, one that brings us back to our central question. What if the fragmentation was intentional? What if Atlas was designed to break apart at precisely this distance from the Sun, at precisely this time? The controlled nature of the fragmentation, the way the pieces separated so gracefully, suggests a level of structural engineering that seems almost purposeful. Consider how we might design a space probe to sample multiple locations in a planetary system. We could build a single large probe, but that would limit us to one trajectory, one set of observations. Or we could build multiple small probes, but that would be expensive and complex to launch. A third option would be to build a carrier probe that releases smaller probes at the appropriate time, each one targeted at a different objective. The carrier would appear to break apart, but this would be by design, not accident. Now imagine applying this concept to a comet-like object. The main body could be designed to fragment at a specific distance from the Sun, releasing smaller components that would follow slightly different trajectories. Some might be targeted at Earth, others at Mars or Venus. Some might be designed to sample the solar wind, others to observe the Sun itself. To any observer, it would look like a natural comet fragmenting, but it would actually be a sophisticated deployment of multiple observation or communication platforms. The fragments of Atlas continued their journey toward the Sun through April and May 2020, gradually fading as they dispersed. By the time of perihelion on May 31st, they were barely visible even in large telescopes. The great comet that wasn't, as disappointed observers called it. But perhaps this misses the point entirely. Perhaps Atlas achieved exactly what it was designed to achieve. Let's consider what happened to all the material released by Atlas during its fragmentation and dissolution. We're talking about millions, perhaps billions of tons of gas and dust, spread across a volume of space millions of kilometers across. This material didn't vanish. It continued to orbit the Sun, gradually spreading out along Atlas's orbital path. Some of it was blown outward by the solar wind, but much of it remained in the inner solar system, a vast diffuse cloud of particles ranging from molecules to pebbles. Earth, in its orbit around the Sun, will eventually pass through some of this material. When it does, the smaller particles will enter our atmosphere, creating meteors, those brief streaks of light we call shooting stars. The larger particles might survive the plunge through the atmosphere, reaching the ground as meteorites. In this way, pieces of Atlas will literally fall to Earth, becoming part of our world in the most physical sense. But what if these particles are more than just comet dust? What if hidden among the natural particles are artificial ones designed to survive atmospheric entry and deliver their cargo to Earth's surface? These wouldn't need to be large or obvious. They could be microscopic, indistinguishable from natural cosmic dust except at the molecular or atomic level. They could be designed to interact with Earth's environment in specific ways, perhaps even with Earth's biosphere. This is not pure fantasy. We know that material can be exchanged between planets naturally. Meteorites from Mars have been found on Earth, blasted off the red planet by asteroid impacts and eventually falling to our world. If nature can transfer rocks between planets, why couldn't an intelligence transfer information or even technology in the same way? The beauty of this delivery system is its subtlety. There would be no dramatic landing, no obvious alien artifact for governments to cover up or scientists to study. Just a gentle rain of particles, most natural, a few perhaps not, falling across the entire planet over months or years. It would be the ultimate in soft disclosure, a message delivered not with fanfare but with whispers. As we trace the journey of Atlas from discovery to dissolution, we can see a pattern that seems almost too perfect to be natural. It appeared just as humanity was developing the technology to observe it in detail. It brightened dramatically, ensuring it would be noticed and studied. It fragmented in a controlled manner, dispersing its contents across the inner solar system. And it did all this while maintaining perfect plausibility as a natural comet. If Atlas was artificial, its creators understood not just physics and chemistry but psychology. They understood that a civilization like ours, just beginning to explore space, would be more receptive to a gentle introduction than a dramatic revelation. They understood that the best way to deliver a message might be to make it look like no message at all, to hide it in plain sight among natural phenomena. But even if Atlas was entirely natural, its story still carries profound implications. It reminds us that we live in a dynamic solar system where objects from the distant past periodically visit our neighborhood. It shows us that our planet is not isolated but connected to the larger cosmos through a constant exchange of material, and it demonstrates that even with all our technology and knowledge, nature can still surprise us. The observation of Atlas also highlighted the global nature of modern astronomy. The comet was discovered by a survey in Hawaii, observed by astronomers on every continent, and studied by space telescopes orbiting Earth. Data was shared in real time across the internet, allowing anyone with a computer to follow the comet's progress. It was a demonstration of humanity's collective ability to observe and understand cosmic phenomena. This global collaboration is perhaps a preview of how we might respond to a more definitive sign of extraterrestrial intelligence. If we ever do receive an unambiguous message from another civilization, it won't be the property of any one nation or organization. It will belong to all humanity, requiring a coordinated global response. The way we came together to observe Atlas, sharing data and insights across borders and cultures, suggests we might be more ready for such an event than we think. As the fragments of Atlas faded from view in late May 2020, they left behind more than just dust and gas. They left questions. Why did it brighten so rapidly? Why did it fragment when and how it did? Was there something unusual about its composition that we missed? These questions may never be fully answered, but they will inform our observation of future comets, making us more attentive to anomalies, more open to unexpected behaviors. The story of Atlas also coincided with a unique moment in human history. As the comet was brightening in March 2020, the world was entering lockdown due to the COVID-19 pandemic. While humans were confined to their homes, isolated from each other, Atlas was crossing vast distances of space, a reminder that the universe continued its ancient patterns regardless of human affairs. There was something poignant about this cosmic visitor arriving just as humanity was experiencing its own fragmentation and isolation. Yet there was also something hopeful about it. Even in lockdown, astronomers continued to observe. Even in isolation, people shared images and observations online. Even in crisis, humanity maintained its curiosity about the cosmos. Atlas became a point of connection, something we could all look up at, or at least read about, and wonder about together. It was a reminder that we are united by our shared sky, our common heritage as children of the cosmos. The pandemic also gave many people time to contemplate bigger questions. With normal life disrupted, with the fragility of human civilization suddenly apparent, questions about our place in the universe took on new urgency. Are we alone? Is there other life out there? What is our purpose, our destiny as a species? Atlas, arriving at this moment of contemplation, seemed to embody these questions in physical form. Now, as we look back on Atlas from a distance of several years, we can see it as part of a larger pattern. It was one of several unusual objects detected in recent years, including Oumuamua in 2017 and Comet Borisov in 2019. Each of these objects challenged our expectations in different ways. Oumuamua, with its unusual shape and acceleration, Borisov with its clearly interstellar origin, and Atlas with its rapid brightening and controlled fragmentation. Are these objects related? Are they part of a coordinated survey of our solar system by one or more extraterrestrial civilizations? Or are they simply natural objects that happen to be unusual, outliers in the normal distribution of comets and asteroids? We don't know, and perhaps we can't know with our current level of technology and understanding. But the very fact that we're asking these questions, that we're looking more carefully at celestial visitors, means we're more likely to notice if something truly anomalous appears. The legacy of Atlas extends beyond astronomy. It has entered popular culture, inspiring artists, writers, and musicians. Its story has been told in documentaries and podcasts, analysed in scientific papers and blog posts. It has become part of our collective narrative, another chapter in humanity's long relationship with comets. And perhaps most importantly, it has inspired young people to look up, to wonder, to consider careers in astronomy or space science. This inspirational aspect shouldn't be underestimated. Every generation needs its cosmic wonders, its celestial events that capture imagination and inspire dreams. For some, it was Halley's Comet in 1986 or Hale-Bopp in 1997. For others, it was Shoemaker-Levy 9's collision with Jupiter in 1994. For the generation coming of age in 2020, Atlas might be that touchstone, that first glimpse of cosmic grandeur that sets a life trajectory toward the stars. As we continue to monitor the debris from Atlas, tracking its dispersal through the solar system, we're also watching for the next visitor. The Atlas Survey and others like it continue their patient vigil, scanning the sky night after night, looking for moving points of light. They've already discovered hundreds of asteroids and dozens of comets, and they'll discover many more in the years to come. Each discovery adds to our understanding of the solar system, our knowledge of what's normal and what's not. And perhaps one day, one of these surveys will detect something that is unambiguously artificial, something that can't be explained as a natural phenomenon. When that day comes, we'll be ready, in part because of objects like Atlas that have taught us to look more carefully, think more creatively, and remain open to possibilities we haven't yet imagined. The infrastructure of observation, the protocols for verification, the channels for communication, all of these have been tested and refined through the observation of objects like Atlas. But even if that day never comes, even if every comet turns out to be exactly what it appears to be, a ball of ice and rock from the outer solar system, the search itself has value. It connects us to the cosmos, reminds us of our place in the grand scheme of things, and keeps alive the sense of wonder that makes us human. Atlas, whether natural or artificial, succeeded in this mission. It made us look up, made us wonder, made us dream. The dust from Atlas is still out there, orbiting the Sun, slowly dispersing through the inner solar system. Some of it has already reached Earth, falling as meteors in our night sky. More will arrive in the years to come, a gentle rain of cosmic material that connects us physically to our mysterious visitor. Each particle carries with it the memory of Atlas's journey, from the cold depths of space to the warm inner solar system, from darkness to light to darkness again. In a sense, we are all made of comet dust. The water in our bodies, the carbon in our DNA, the iron in our blood. All of these elements were once part of the primordial cloud from which our solar system formed. Some of this material was processed through stars, blown into space by supernova and incorporated into new stellar systems. Some of it has been preserved in comets since the beginning, waiting billions of years to fall sunward and perhaps become part of a living world. Atlas has now joined this cosmic recycling system. Its atoms will eventually be incorporated into new objects, planets, moons, perhaps even new comets. Billions of years from now, long after humanity has either transcended or vanished, the atoms that once made up Atlas will still be part of the solar system, continuing their eternal dance around the Sun. In this way, Atlas achieves a kind of immortality, becoming part of the ongoing story of our cosmic neighborhood. But the story of Atlas is far from over. As we develop new technologies, new ways of observing and analyzing cosmic phenomena, we may discover things about Atlas that we missed the first time. Perhaps analysis of its dust, collected by high-altitude aircraft or satellites, will reveal unusual isotope ratios or molecular structures. Perhaps careful study of its orbital dynamics will show subtle anomalies that hint at artificial origin. Perhaps comparison with other comets will highlight just how unusual Atlas really was. Or perhaps we'll discover that Atlas was perfectly natural, but that its unusual behavior teaches us something new about comets, about the solar system, about the processes that shape worlds. Either outcome would be valuable. Science progresses both through confirming hypotheses and through ruling them out. Every question answered leads to new questions. Every mystery solved reveals new mysteries. The fragmentation of Atlas, that slow, graceful dissolution we witnessed in April 2020, continues to fascinate researchers. High-resolution images from Hubble and ground-based telescopes are still being analysed, revealing new details about how the fragments separated and evolved. Each fragment seemed to have its own personality, its own pattern of brightening and fading, its own trajectory through space. It was as if Atlas didn't just break apart, but gave birth to a family of smaller comets, each carrying part of the original's essence. Some of these fragments may still be out there, too faint to detect with current technology but still orbiting the Sun. They might return to the inner solar system in decades or centuries, appearing as new comets with their own designations. Future astronomers might not even realize they're seeing pieces of Atlas, unless careful orbital analysis reveals the connection. In this way, Atlas's influence extends far into the future, a gift to astronomers yet unborn. The timing of Atlas's appearance and fragmentation also raises interesting questions about observation bias. We detected Atlas because we happened to be looking with the right instruments at the right time. How many similar objects have passed through our solar system unnoticed? How many are passing through right now, too faint or too far away for our current surveys to detect? The universe might be full of Atlas-like objects, and we've only just developed the ability to see them. This is both humbling and exciting. Humbling because it reminds us how much we still don't know, how many cosmic events occur without our knowledge. Exciting because it means there's so much still to discover, so many surprises waiting in the darkness. Every improvement in our detection capabilities, every new survey that comes online, increases our chances of finding something extraordinary. The Atlas survey itself, the system that discovered our mysterious visitor, continues to improve. New telescopes are being added, software is being refined, and detection algorithms are becoming more sophisticated. What might have been missed a few years ago can be detected today. What escapes detection today might be caught tomorrow. We are in a golden age of discovery, where patient electronic eyes scan the heavens continuously, where any night might bring news of a new visitor from the cosmic deep. As we contemplate the story of Atlas, we should also consider what message we might send if we were to launch our own comet-like probe to another star system. How would we design it to survive the journey? How would we ensure it would be noticed but not seem threatening? How would we encode information in a way that could be decoded by beings whose thought processes might be utterly unlike our own? These are not just theoretical questions. As our technology advances, we may actually face these decisions. We've already sent the Voyager probes into interstellar space. Future missions might be designed to reach other star systems, carrying messages or even seeds of life. In thinking about what Atlas might have been, we're also thinking about what we might create, what legacy we might leave for civilizations we'll never meet. The story of Atlas also highlights the importance of amateur astronomers in modern astronomy. While the comet was discovered by a professional survey, much of the follow-up observation was done by amateurs with modest equipment. These dedicated individuals, observing from their backyards and driveways, contributed valuable data that helped track Atlas's evolution. They were often the first to notice changes, like the initial elongation that signaled fragmentation. This democratization of astronomy is one of the great developments of our time. With relatively inexpensive equipment and internet connections, anyone can contribute to our understanding of the cosmos. The same sky that inspired our ancestors to create myths and legends now inspires citizen scientists to make real discoveries. Atlas was observed by thousands of people around the world, each adding their small piece to the larger puzzle. The data from all these observations is preserved in archives that will be available to future researchers. Decades from now, someone might analyze this data with techniques we haven't yet invented. discovering patterns we couldn't see. The story of Atlas will continue to be written long after the comet itself has faded from memory. This is the power of modern astronomy. Every observation becomes part of a permanent record, a resource for future discovery. As we near the end of this part of our journey with Atlas, from its discovery to its dissolution, we can see how a single comet can touch so many aspects of human experience. It connects us to the deep past and the far future. It unites us across cultures and continents. It challenges our understanding and expands our imagination. It reminds us that we are part of something vast and ancient and ongoing. The brightness of Atlas, that remarkable increase that caught everyone's attention, might have been its most important feature. Not because it made the comet spectacular to see, but because it ensured the comet would be studied intensively. If Atlas had remained faint, it might have passed through our solar system with little notice, just another long-period comet among hundreds. But by brightening so dramatically, it demanded attention, ensuring that its every behavior would be documented, analyzed, discussed. Was this intentional? Did something or someone want Atlas to be noticed? Or was it simply a fortunate accident that this particular comet happened to be rich in volatile materials that produced such a bright display? We may never know for certain, but the question itself is valuable. It keeps us alert to possibilities, prevents us from becoming complacent in our understanding of the cosmos. The rapid brightening also created a natural experiment in public science communication. As news of the potentially spectacular comet spread, science communicators had to balance excitement with uncertainty. How do you convey the possibility of a great comet while also preparing people for disappointment? How do you explain the unpredictability of comets without discouraging interest? These are important questions in an age where science is often misunderstood or misrepresented. The fragmentation of Atlas provided another communication challenge. How do you explain that the comet dying was actually scientifically valuable? That we often learn more from a comet that breaks apart than from one that remains intact? The public wanted a spectacular show, but scientists were excited by the opportunity to see inside a comet, to observe materials that had been locked in its interior for billions of years. This tension between public expectation and scientific value is common in astronomy. The public is often drawn to the spectacular, the brightest stars, the biggest explosions, the most dramatic events. But scientists know that the most important discoveries often come from careful observation of subtle phenomena, from things that are barely visible, from events that unfold over years or decades rather than minutes or hours. Atlas bridged this gap in an interesting way. It promised spectacle but delivered science. It caught public attention with its brightness, but rewarded scientific attention with its fragmentation. It was both a public event and a research opportunity, a reminder that science doesn't happen in isolation, but as part of human culture. The media coverage of Atlas was also instructive. In an era of instant communication and social media, news of the comet spread rapidly, sometimes faster than scientists could verify observations. Rumors and speculation mixed with facts. Images were shared, some real, some enhanced, some completely fabricated. It was a case study in how scientific information propagates in the digital age, with all the opportunities and challenges that entails. Yet despite the confusion and occasional misinformation, the overall effect was positive. People learned about comets, about astronomical observation, about the dynamic nature of our solar system. Children asked their parents to take them outside to look for the comet. Students researched comets for school projects. Amateur astronomers joined online forums to share observations and techniques. Atlas became a gateway to broader interest in astronomy and science. This educational aspect is perhaps one of Atlas's most important legacies. Every comet that captures public attention creates a new generation of astronomy enthusiasts, some of whom will become the next generation of professional astronomers. They'll be the ones operating the telescopes, analyzing the data, making the discoveries that expand our understanding of the universe. In this way, Atlas's influence extends far beyond its brief appearance in our skies. As we watch the last traces of Atlas fade into the cosmic background, we're left with a profound sense of gratitude for this mysterious visitor. Whether it was a simple comet or something more, it gave us a gift. It reminded us to look up, to wonder, to question. It connected us to the cosmos and to each other. It challenged our assumptions and expanded our possibilities. It was, in every sense, a messenger from the depths of space and time. The story now shifts to what Atlas left behind, not just the physical debris spreading through the solar system, but the data, the observations, the subtle anomalies that continue to puzzle researchers. As we dive deeper into the scientific analysis of Atlas, we'll explore what made this comet unique, what the data really shows, and what gaps in our knowledge it revealed. The mystery deepens as we look closer, as we examine the ghost in the data that Atlas left for us to decipher. In the months following Atlas's fragmentation, as the initial disappointment of the failed spectacle gave way to scientific analysis, researchers began to notice things that didn't quite fit the standard comet model. The data was extensive, thousands of images from ground-based telescopes, hundreds of spectra showing chemical composition, precise measurements of brightness variations, detailed tracking of the fragment's trajectories. It was in this data that the ghost of Atlas began to emerge, not as a single dramatic revelation, but as an accumulation of small anomalies, subtle deviations from the expected. The first anomaly was the rate of brightening. When astronomers plot a comet's brightness against its distance from the Sun, they expect to see a smooth curve following a power law. Atlas's curve was anything but smooth. It showed sudden jumps in brightness that couldn't be explained by changes in distance alone. These jumps occurred at seemingly random intervals, lasting for hours or days before the brightness returned to the expected trend. It was as if something inside the comet was turning on and off, generating bursts of activity that had nothing to do with solar heating. One particularly intriguing brightness spike occurred on March 19, 2020, when Atlas suddenly brightened by almost a full magnitude in less than 6 hours. This was captured by multiple observers around the world, ruling out instrumental error or atmospheric effects. The comet literally flared up, increasing its light output by a factor of 2.5, then gradually returned to its previous brightness over the next day. No jets were observed that could account for such a dramatic change. No fragments broke off that observers could detect. The comet simply got brighter, then dimmer, with no obvious cause. Spectroscopic observations added another layer of mystery. The spectrum of a comet tells us what molecules are present in its coma, like a chemical fingerprint of its composition. Atlas's spectrum showed all the expected molecules: water, carbon dioxide, carbon monoxide, various simple organic compounds. But the ratios were off. There was too much carbon monoxide relative to water, too much diatomic carbon relative to other carbon compounds. These ratios suggested that Atlas was either from a very different region of the solar system than most comets, or it had undergone some unusual processing that altered its composition. Even more puzzling were the trace elements detected in Atlas's spectrum. Several observers reported detecting emission lines that didn't match any known cometary molecules. These lines were faint, right at the edge of detectability, but they appeared consistently in spectra taken by different instruments. Some researchers suggested they might be from unusual isotopes or rare molecules, but others wondered if they might be from something else entirely, perhaps artificial compounds designed to be noticed by anyone analysing the comet's light. The morphology of Atlas's coma was also unusual. Most comets show a roughly spherical coma with jets or fans extending in specific directions. Atlas's coma was strangely structured, with what appeared to be concentric shells of material, like ripples in a pond. These shells expanded outward at regular intervals, suggesting periodic releases of material from the nucleus. But the periodicity didn't match the comet's rotation rate, ruling out the simple explanation of active areas rotating into sunlight. High-resolution images from large telescopes revealed even more structure within the coma. There appeared to be helical patterns, spirals of dust and gas that wound around the comet, like a cosmic DNA strand. These spirals were not random. They showed a mathematical regularity that some researchers found almost too perfect to be natural. It was as if the comet was generating these patterns deliberately, encoding information in the very structure of its coma. The fragmentation of Atlas, when examined closely, showed its own set of anomalies. Typically, when a comet fragments, the pieces follow very similar orbits, gradually drifting apart due to small differences in velocity. The fragments of Atlas, however, showed unexpected accelerations. Some pieces sped up, others slowed down, and these changes couldn't be fully explained by outgassing or solar radiation pressure. One fragment, designated Atlas D by researchers, showed particularly anomalous behavior. After separating from the main body, it maintained a constant brightness for several days, then suddenly flared up, becoming briefly brighter than all the other fragments combined. Then it faded rapidly and disappeared entirely, not gradually dimming like a normal comet fragment, but vanishing as if someone had flipped a switch. No debris was observed that could account for its disappearance. It was simply gone. The trajectory analysis of the fragments revealed another puzzle. When astronomers calculated backward to determine when and how the fragmentation began, they found that the fragments must have started separating while the comet was still very far from the Sun, possibly as far out as Jupiter's orbit. But the comet appeared intact in observations from that time. Either the fragmentation began much earlier than the comet showed visible signs of breaking apart, or something else was happening that we don't understand. The dust trail left by Atlas was also unusual. Most comets leave a trail of dust particles along their orbit, and the distribution of these particles can tell us about the comet's history of activity. Atlas's dust trail showed distinct clumps and gaps, as if material had been released in discrete bursts rather than continuously. These bursts didn't correlate with the comet's distance from the Sun or any observed outbursts. It was as if the comet had been releasing material according to some internal schedule rather than in response to external heating. Polarimetry measurements, which analyze how light from the comet is polarized, revealed yet another anomaly. The polarization of light scattered by comet dust typically follows predictable patterns based on the size and composition of the particles. Atlas's dust showed unusual polarization properties, suggesting either that the particles had an unusual shape or composition, or that some of them were not dust at all but something else masquerading as dust. Radio observations of Atlas detected something unexpected as well. Several radio telescopes reported brief, narrow-band emissions from the comet's vicinity. These emissions lasted only seconds and didn't repeat, making them difficult to verify. They could have been terrestrial interference or equipment malfunction, but their apparent association with the comet's position was intriguing. If real, they suggested that Atlas was not just passively sublimating, but actively transmitting something. The chemical analysis of Atlas's composition revealed isotope ratios that didn't match any known reservoir in the solar system. The ratio of deuterium to hydrogen in its water was different from both Oort cloud comets and Kuiper belt objects. The carbon isotope ratios were similarly anomalous. Either Atlas came from a region of the solar system we haven't sampled before, or it came from outside the solar system entirely, or its isotopes had been artificially altered. One of the most intriguing discoveries came from analysis of archived data. Researchers looking back through old survey images found what might have been Atlas in images from 2018, a full year before its official discovery. But the object in these images was much fainter than it should have been based on Atlas's orbit. Either Atlas suddenly brightened by a factor of 100 between 2018 and 2019, or the object in the old images was something else that happened to be in the same position. Neither explanation was fully satisfactory. The timing of Atlas's brightening events showed a curious pattern when analysed statistically. The intervals between major brightening events were not random, but followed a mathematical sequence that some researchers recognized as similar to patterns used in communication theory. It was as if the comet was transmitting information through its brightness variations, using a code based on mathematical constants that any technological civilization would recognize. Temperature measurements of Atlas's coma revealed it was warmer than expected based on solar heating alone. The excess heat could have come from exothermic chemical reactions within the comet, but the amount of excess heat was difficult to explain with known cometary chemistry. Some researchers suggested that radioactive decay might be responsible, but the isotopes required would be unusual for a comet. Others wondered if the heat might be generated by something else entirely, perhaps some form of technology embedded within the ice. The velocity of gas escaping from Atlas was also anomalous. Measurements of the Doppler shift of emission lines in its spectrum showed that gas was leaving the nucleus at speeds higher than thermal velocities would predict. Something was accelerating the gas beyond what simple sublimation could achieve. This could be explained by explosive releases of gas from pressurized pockets within the comet, but the consistency of the excess velocity suggested a more systematic process. Magnetic field measurements near Atlas, made by spacecraft monitoring the solar wind, showed unexpected disturbances. As the solar wind flowed past the comet, it showed perturbations that suggested Atlas had a weak but detectable magnetic field. Comets can generate magnetic fields through their interaction with the solar wind, but Atlas's field was stronger and more organized than expected. It was as if the comet contained ferromagnetic materials or was generating its own magnetic field through some unknown process. The distribution of fragment sizes after Atlas broke apart followed an unusual pattern. In natural fragmentation events, we expect to see a power law distribution of fragment sizes, with many small pieces and few large ones. Atlas's fragments showed a more uniform size distribution, as if the comet had broken along predetermined fracture planes rather than randomly shattering. This suggested a level of structural organization within the nucleus that was hard to explain for a random aggregation of ice and rock. Some observers reported seeing transient features in Atlas's coma that appeared and disappeared too quickly to be properly documented. These included straight lines or rays that didn't align with the solar direction, geometric patterns that lasted for minutes before dissolving, and what some described as pulse waves that seemed to propagate outward from the nucleus at regular intervals. These observations were often dismissed as artifacts or misinterpretations, but the consistency of the reports from independent observers was notable. The color of Atlas changed in unexpected ways as it approached the sun. Most comets show gradual color changes as different ices sublimate at different temperatures, but Atlas showed sudden color shifts that reversed themselves days later. It would appear greenish one week, bluish the next, then back to green. These changes didn't correlate with any observed changes in composition or activity level. It was as if the comet was cycling through different states or modes of operation. Analysis of the finest dust particles in Atlas's coma, based on how they scattered light, suggested some particles were much smaller than typical cometary dust. These nanoparticles, if that's what they were, would have properties very different from larger dust grains. They could potentially carry information at the molecular level, act as catalysts for chemical reactions, or serve functions we haven't yet imagined. Their presence in such quantities was unexpected for a natural comet. The trajectory of Atlas itself, when analysed with the highest precision possible, showed tiny anomalies that couldn't be explained by gravitational forces alone. Even accounting for outgassing and radiation pressure, there were small accelerations that didn't fit the models. These anomalies were at the very edge of measurement precision, and some researchers dismissed them as errors, but others noted that similar anomalies had been seen in other unusual objects like Oumuamua. Perhaps most intriguingly, several research groups independently noted that many of Atlas's anomalies seemed to be correlated. The brightness outbursts often coincided with color changes. The unusual spectral lines appeared strongest during fragmentation events. The magnetic field perturbations aligned with the dust release patterns. It was as if all these anomalies were different aspects of a single underlying phenomenon, different views of the same mysterious process. As researchers compiled and cross-referenced all these anomalies, a picture began to emerge of a comet that was anything but typical. Every aspect of Atlas, from its composition to its behavior to its demise, showed deviations from the norm. Any single anomaly could be dismissed as a statistical fluke or measurement error, but the sheer number and consistency of the anomalies suggested something more. Some researchers began to speak privately about the Atlas problem, the difficulty of explaining all the observations within the framework of conventional cometary science. Papers were written proposing exotic explanations. Atlas was from the hypothetical Planet 9's Oort cloud. Atlas was a contact binary that separated during approach. Atlas contained exotic ices never before seen in comets. But none of these explanations could account for all the anomalies. A few brave souls ventured further, suggesting in hushed conversations at conferences that maybe, just maybe, Atlas wasn't entirely natural. They pointed to the mathematical patterns in its brightness variations, the too perfect spirals in its coma, the unexplained emissions, the anomalous trajectory. They noted how many of the anomalies seemed designed to be noticed by anyone paying close attention, like signatures or calling cards left by the comet's creators. But the scientific community is conservative by nature and training. Extraordinary claims require extraordinary evidence, and while Atlas was certainly extraordinary, the evidence for artificial origin remained circumstantial. No one had found a clearly artificial component, no undeniable proof of technology. The anomalies were suggestive but not conclusive. Atlas remained officially classified as a natural comet, albeit an unusual one. Yet the questions lingered. In private conversations, in late-night discussions after conference sessions, in speculative papers posted to preprint servers, researchers continued to puzzle over Atlas. What was it really? Where did it really come from? Why did it behave the way it did? And perhaps most importantly, what did it leave behind? The data from Atlas continues to be analysed years after the comet faded from view. New techniques are applied, new patterns are sought, new explanations are proposed. Each research group has its own piece of the puzzle, its own anomaly to explain. Slowly, gradually, a more complete picture may emerge, or perhaps the mystery will only deepen, each answer revealing new questions, each solution opening new puzzles. This is the nature of scientific discovery. It's not a linear path from ignorance to knowledge, but a wandering journey through a landscape of mystery. Sometimes we think we understand something, only to realize we've been looking at it from the wrong angle. Sometimes an anomaly that seems important turns out to be irrelevant, while a detail we ignored holds the key to everything. Atlas has become a test case for how we deal with anomalous observations. Do we force them into existing frameworks, explaining them away with increasingly complex conventional theories? Do we ignore them, focusing on comets that behave as expected? Or do we embrace the anomalies, following them wherever they lead, even if that means questioning our basic assumptions about the nature of comets and perhaps the solar system itself? The ghost in the data of Atlas is more than just a collection of anomalies. It's a challenge to our understanding, an invitation to think differently, a reminder that the universe is under no obligation to conform to our expectations. Whether Atlas was natural or artificial, conventional or exotic, it has served a valuable purpose. It has made us look more carefully, think more creatively, and remain open to possibilities we hadn't previously considered. As new comets are discovered and observed, astronomers now look for Atlas-like characteristics. Has the brightness curve shown unexpected jumps? Are there unusual patterns in the coma structure? Do the isotope ratios match known reservoirs? Atlas has become a reference point, a standard of weirdness against which other comets are measured. In this way, its influence extends far beyond its brief appearance in our skies. The data archives containing Atlas observations have become a resource for testing new theories and techniques. Machine learning algorithms are trained on Atlas data to look for patterns human observers might have missed. Statistical analyses search for correlations between different anomalies. Simulations attempt to reproduce Atlas's behavior using various physical models. The comet has become a digital laboratory where ideas can be tested and refined. Some researchers have suggested that Atlas might be part of a larger population of anomalous objects that we're only now beginning to recognize. They point to Oumuamua, Comet Borisov, and other recent discoveries that don't quite fit our expectations. Perhaps these objects represent a new class of celestial bodies, or perhaps they're showing us that our classification schemes are too narrow, that nature is more varied than we assumed. The possibility that Atlas was artificial, while not accepted by mainstream science, has inspired serious discussion about how we would recognize an artificial object if we saw one. What signatures would distinguish technology from nature at astronomical scales? How would an alien probe disguise itself? What kinds of missions might extraterrestrial civilizations send to other star systems? These questions, sparked by Atlas and similar objects, are gradually moving from science fiction to scientific discourse. The search for techno-signatures, signs of technology in astronomical observations, has gained new urgency and sophistication, partly because of objects like Atlas. Researchers are developing new frameworks for analyzing anomalous observations, new criteria for distinguishing natural from artificial phenomena, new protocols for investigating objects that don't fit conventional categories. Atlas has helped catalyze a shift in how we think about the search for extraterrestrial intelligence. But even if Atlas was entirely natural, its scientific value is immense. It has shown us that comets can behave in ways we didn't expect, that our models are incomplete, that there's still much to learn about these ancient objects. It has provided a wealth of data about fragmentation processes, about the relationship between composition and activity, about the dynamics of cometary comas. Graduate students will be analyzing Atlas data for years to come, finding new insights in old observations. The public fascination with Atlas has also had lasting effects. Science museums have created exhibits about comets featuring Atlas prominently. Planetarium shows tell its story, from discovery to dissolution. Educational materials use Atlas as an example of how science deals with unexpected observations. The comet has become a teaching tool, a way to illustrate scientific methodology and the excitement of discovery. Artists and writers have found inspiration in Atlas as well. Its story of promise and fragmentation, of brightness and fading, resonates on a metaphorical level. It has been the subject of poems and paintings, music and fiction. The image of Atlas breaking apart, its fragments drifting through space like seeds on the wind, has become a powerful symbol of transformation and dispersal. The timing of Atlas's appearance, during the early months of the COVID-19 pandemic, has given it additional symbolic weight. While humanity was experiencing its own kind of fragmentation, with societies locked down and isolated, Atlas was undergoing its literal fragmentation in the sky above. The parallel was not lost on many observers, who saw in the comet a cosmic reflection of earthly events. As we continue to study the data from Atlas, new anomalies occasionally surface. A researcher notices an odd pattern in the light curve that hadn't been recognized before. Someone finds an archival image that doesn't quite match the expected position. A new analysis technique reveals structure in the spectrum that was previously hidden in the noise. The ghost in the data continues to manifest in new ways, keeping the mystery alive. The fragments of Atlas, those pieces that drifted apart in April 2020, followed different paths through the inner solar system. Some passed close to Earth's orbit, others headed toward Mars or Venus. Each fragment carried with it part of Atlas's mystery, part of its anomalous nature. Tracking these fragments became a priority for some researchers, hoping to catch one last glimpse, one final clue to the comet's nature. But the fragments faded quickly, becoming too faint for even large telescopes to detect. They dissolved into the background of cosmic dust that fills the inner solar system, becoming part of the zodiacal light, that faint glow visible in dark skies after sunset or before sunrise. In a sense, Atlas became part of the permanent infrastructure of our solar system, its dust joining the ancient circulation of material between planets. This dust will eventually fall onto planets and moons throughout the inner solar system. Some of it has already reached Earth, entering our atmosphere as meteors or settling gently onto the surface as microscopic particles. We breathe air that contains atoms from Atlas. We drink water that might include molecules the comet carried. In the most literal sense, Atlas has become part of our world. The possibility that Atlas was something more than a simple comet opens doorways in our imagination that lead to profound questions about the nature of intelligence in the universe. As we drift deeper into speculation, guided by the anomalies we've discovered but unconstrained by the need for proof, we can explore what it might mean if Atlas was indeed a form of interstellar probe, a messenger disguised as a natural phenomenon. This is not science in the strict sense, but rather an exercise in expanding our conceptual horizons, in preparing our minds for possibilities that may one day move from speculation to reality. Imagine for a moment that somewhere in the galaxy, perhaps around a star we've catalogued but never truly studied, there exists a civilization that has been watching the cosmos for millions of years. They have long since moved beyond the crude rockets and radio transmissions that mark our current technological adolescence. They have developed ways of exploring the galaxy that we can barely conceive, methods that work on timescales and distances that dwarf human experience. For such a civilization, sending probes to other star systems might be as routine as we find sending satellites into Earth orbit. But these probes would not look like our spacecraft, all metal and solar panels and obvious artificiality. A truly advanced civilization would understand that the best way to study other systems, especially systems that might harbour life, is to remain undetected, to observe without disturbing. They would create probes that mimic natural objects, that follow natural trajectories, that behave in ways that wouldn't trigger alarm or even notice from young civilizations still learning to look at the sky. A comet is the perfect disguise. Comets are common enough to not raise suspicion, but rare enough that each one is studied individually. They have a reason to enter the inner solar system where planets and potential life reside. They naturally break apart and disperse material, providing a mechanism for distributing sensors or samples across multiple worlds. They eventually leave or dissipate, removing evidence of their presence. If you were designing a stealth probe to study other solar systems, you could hardly do better than making it look and act like a comet. The construction of such a probe would require technologies we're only beginning to imagine. It would need to survive millions or billions of years in interstellar space, maintaining its integrity and its disguise through extremes of cold and radiation. It would need navigation systems that could guide it across light years with extraordinary precision, arriving at exactly the right place at exactly the right time. It would need to activate at the appropriate moment, beginning its performance as a natural comet just as it became visible to any watching civilization. Perhaps most impressively, it would need to maintain its disguise even under close scrutiny. The ice would need to be real ice, with the right isotope ratios and chemical composition to seem natural. The dust would need to be genuine cosmic dust, or at least indistinguishable from it. Any technological components would need to be hidden deep within the nucleus, or perhaps distributed at the molecular level throughout the ice, invisible until activated. This is where the concept of smart dust becomes relevant. Imagine particles so small they're invisible to the naked eye, each one containing sensors, processors, and communication systems at the nanoscale. These particles could be mixed throughout the comet's ice, dormant for millions of years, activating only when certain conditions are met. As the comet sublimates, these particles would be released into space, spreading throughout the inner solar system like seeds on the wind. Each particle could be programmed with specific functions. Some might be designed to sample planetary atmospheres, riding air currents for years while analyzing chemical compositions and searching for biosignatures. Others might settle onto surfaces, conducting geological surveys or searching for signs of life. Still others might remain in space, forming a distributed sensor network that could monitor electromagnetic emissions, track objects, or relay information back to some central collection point. The beauty of this approach is its subtlety. There would be no dramatic landing, no obvious alien artifact for governments to cover up or scientists to study. Just a gradual infiltration of smart particles throughout the solar system, so small and so dispersed that they would be virtually impossible to detect with our current technology. They could be all around us right now, and we would never know. The fragmentation of Atlas takes on new meaning in this context. Rather than being a failure or a natural breakdown, it could have been a carefully orchestrated deployment. Each fragment could have been targeted at a different part of the inner solar system, carrying specialized sensors or probes designed for specific environments. The timing of the fragmentation, when Atlas was still relatively far from the Sun, would have allowed the fragments to spread widely, ensuring coverage of multiple planets and regions. The anomalous accelerations observed in some fragments could have been intentional course corrections, subtle adjustments to ensure each fragment reached its intended destination. The fragment that flared up and then disappeared completely might have been deploying something, exhausting its energy reserves in one final burst of activity before going dark. The mathematical patterns in the brightness variations could have been status signals, confirming successful deployment or transmitting collected data. But why would an alien civilization go to such lengths to study our solar system? The answer might lie in the universality of curiosity. Any intelligence that has survived long enough to develop interstellar technology must have an intense drive to understand the universe around it. They would want to know if life exists elsewhere, what forms it takes, how it evolves. They would be especially interested in technological civilizations, rare jewels in the cosmic darkness that represent potential friends, threats, or simply fascinating subjects for study. Earth, with its obvious biosignatures visible from interstellar distances, would be a prime target for such investigation. Our oxygen-rich atmosphere, the spectral signature of chlorophyll, the recently emerging radio emissions, all these would mark our planet as interesting to any civilization conducting a survey of nearby star systems. Sending a probe to investigate would be a logical step, especially if that probe could be disguised as a natural phenomenon. The timing of Atlas's arrival is intriguing in this context. It appeared just as humanity was developing sophisticated enough technology to observe it in detail, but not advanced enough to definitively determine its artificial nature. This could be coincidence, or it could be intentional. Perhaps the probe was programmed to activate when it detected certain technological signatures from Earth, ensuring it would arrive when we were ready to observe it but not ready to fully understand it. This raises fascinating questions about the psychology of whoever might have sent Atlas. They would understand that a developing civilization might not be ready for direct contact, that the sudden revelation of alien intelligence could be destabilizing or traumatic. By disguising their probe as a comet, they allow us to observe and wonder without forcing us to confront the reality of their existence. It's a gentle introduction, a soft disclosure that plants seeds of possibility without demanding immediate acceptance. The information such a probe could gather about our solar system would be invaluable to its creators. Not just data about Earth and its life, but about all the planets, about the solar wind, about the distribution of asteroids and comets, about the chemical and isotopic composition of our cosmic neighborhood. This information could be used for scientific purposes, to understand how solar systems evolve and how life emerges, or it could be used for more practical purposes, to identify resources, to plan future missions, to assess whether our system is worth more detailed investigation. The method of data transmission back to the probe's creators is another fascinating puzzle. Radio signals would be too obvious and too slow for interstellar distances. Perhaps the probe doesn't transmit at all in the conventional sense. Perhaps it releases smaller probes that make their own way back to the home system, carrying physical samples and stored data. or perhaps it uses some form of quantum communication we haven't discovered yet, instantaneously transmitting information across vast distances through mechanisms we don't understand. There's also the possibility that Atlas wasn't meant to transmit data back at all. Perhaps it was a gift, a message, a teaching tool. The anomalies we've observed, the patterns in its behavior, the mathematical regularities in its variations, these could all be intentional, designed to make us think, to expand our understanding, to prepare us for eventual contact. Like a teacher who provides puzzles that lead students to discover principles for themselves, Atlas's creators might have designed it to guide us toward new insights. The specific anomalies observed in Atlas could each have been carefully chosen to convey particular information. The unusual isotope ratios might be telling us about the probe's origin, providing clues to which star system it came from. The mathematical patterns in the brightness variations might be universal constants, or mathematical theorems, a way of saying, we understand the same mathematics you do. The spectral anomalies might be signatures of artificial elements or compounds, proof that the probe's creators have mastered nuclear chemistry. If Atlas was artificial, it represents a technology so advanced it's almost indistinguishable from magic. The ability to create an object that can survive interstellar travel, navigate precisely across light years, maintain a perfect disguise, and execute a complex mission autonomously. This speaks to a level of technological sophistication that might be thousands or millions of years beyond our current capabilities. It's humbling and inspiring in equal measure. But it also raises questions about the nature of intelligence and technology at such scales. Would a civilization that could build something like Atlas still be biological, or would they have long since transitioned to artificial intelligence or some hybrid form we can't imagine? Would they think in terms of individual missions and probes, or would something like Atlas be part of a vast distributed intelligence that spans the galaxy? Would they even distinguish between natural and artificial the way we do? Or would that distinction have become meaningless at their level of development? The idea of Atlas as a ship of dust and dreams captures something essential about what such a probe might represent. The dust is literal, the particles dispersed throughout the solar system, each one potentially carrying information or technology at the molecular level. The dreams are what those particles might embody. The hopes and curiosity of an alien civilization, their desire to understand and connect with other intelligences, their vision of a galaxy where communication and knowledge flow between star systems like rivers connecting distant lakes. If we allow our imagination to run even further, we might consider that Atlas could be more than just a probe. What if it was a seed? What if hidden within its ice were not just sensors and communication devices, but the building blocks of life itself, or instructions for creating it? This touches on the concept of directed panspermia, the idea that life might be deliberately spread throughout the galaxy by advanced civilizations. The organic molecules detected in Atlas's spectrum take on new significance in this context. What if some of those molecules were designed, engineered to interact with existing life in specific ways? They might be catalysts that accelerate evolution, or templates that guide it in particular directions. They might be biological computers, storing vast amounts of information in DNA-like structures. They might even be dormant organisms, waiting for the right conditions to activate and begin reproducing. This is perhaps the most profound possibility of all. That Atlas might have been not just observing life on Earth, but contributing to it. Every meteor from Atlas that enters our atmosphere, every dust particle that settles to the surface, could be carrying biological or technological gifts from another civilization. We might be participating in a cosmic exchange program without even knowing it, receiving genetic or technological innovations from the stars while our own material, blasted off Earth by impacts, makes its way to other worlds. The dissolution of Atlas, seen in this light, becomes almost poetic. Like a dandelion seed head dispersing on the wind, the comet scattered its contents throughout the inner solar system, ensuring that its gifts or messages would reach multiple worlds. Earth, Mars, Venus, the Moon, and countless asteroids would all receive their share. Over time, over millions of years, this material would be processed and reprocessed, becoming part of the ongoing chemical and possibly biological evolution of our solar system. The possibility that we might be breathing in molecules from Atlas, that its atoms might be incorporated into our bodies, creates an intimate connection between us and this mysterious visitor. We're not just observers of Atlas, we have become part of it, and it has become part of us. This is true whether Atlas was natural or artificial, but the possibility of artificiality adds layers of meaning to this connection. We might be carrying within us messages or gifts from another civilization, written in a language we don't yet know how to read. As we contemplate these possibilities, it's important to remember that they remain in the realm of speculation. We have no proof that Atlas was artificial, no smoking gun that definitively reveals an alien hand in its creation. But the exercise of considering these possibilities is valuable in itself. It prepares us mentally and culturally for a universe that might be stranger and more interconnected than we currently believe. It helps us develop the conceptual tools we'll need if we ever do encounter unambiguous evidence of extraterrestrial intelligence. The story of Atlas as a potential artificial probe also highlights the importance of preserving and analysing the data we've collected. Somewhere in those thousands of images, hundreds of spectra and countless measurements, there might be clues we haven't recognised yet. As our technology improves and our understanding deepens, we might find new patterns, new anomalies, new reasons to wonder about the true nature of our mysterious visitor. Future comets will be observed with Atlas in mind. Astronomers will be more alert to anomalies, more willing to consider unconventional explanations, more careful to preserve all data even if it doesn't seem immediately important. Atlas has taught us that comets might be more than they appear, that the universe might be using them as vehicles for purposes we're only beginning to imagine. The possibility of Atlas as an artificial probe also connects to broader questions about our future as a species. If other civilizations are sending sophisticated probes disguised as natural objects, shouldn't we be considering similar approaches for our own exploration of the galaxy? Instead of obvious spacecraft that announce our presence to anyone watching, perhaps we should be developing subtle probes that can observe without being observed, that can gather information without triggering alarm or hostility. This kind of thinking represents a maturation in our approach to the cosmos. We're moving beyond the naive assumption that alien contact would be obvious and dramatic, toward a more nuanced understanding that it might be subtle and ambiguous. We're learning that the universe doesn't owe us clarity, that we might have to work hard to recognize and interpret signs of other intelligences. Atlas, whether natural or artificial, has been part of this education. The cultural impact of Atlas extends beyond astronomy and into philosophy, art, and spirituality. The image of a comet that might have been a messenger, that might have carried gifts or information from another civilization, resonates with deep human longings for connection and meaning. It suggests that we might not be alone, that the universe might be more alive and aware than we thought, that there might be purpose and intention in cosmic events we've dismissed as random. This doesn't require us to abandon scientific skepticism or embrace unfounded beliefs. We can hold these possibilities lightly, as inspirations and invitations rather than dogmas. We can use them to fuel our curiosity and expand our imagination, while still demanding evidence and maintaining critical thinking. Atlas shows us how to live with uncertainty, how to find wonder in mystery without needing immediate resolution. As we near the end of our contemplation of Atlas as a potential ship of dust and dreams, we're left with more questions than answers. What was Atlas really? Where did it come from? What was its purpose? What did it leave behind? These questions may never be definitively answered, but they will continue to inspire and challenge us. They will drive us to look more carefully at future comets, to develop better instruments and techniques, to remain open to possibilities we haven't yet imagined. The legacy of Atlas in this speculative framework is not just the physical material it dispersed through the solar system, but the conceptual seeds it planted in human consciousness. It has made us think differently about comets, about the possibility of alien probes, about the nature of intelligence and technology at cosmic scales. It has prepared us, in some small way, for a future where the distinction between natural and artificial might blur, where messages might come disguised as mundane events, where the universe might be far more alive and intentional than we currently believe. The dreams that Atlas represents, dreams of connection, understanding, and cosmic community, are ultimately human dreams projected onto a cosmic canvas. But perhaps that's appropriate. Perhaps the universe dreams through us, using our consciousness to imagine possibilities that might someday become realities. Perhaps Atlas, whatever its true nature, was part of this cosmic dreaming, a visitor that reminded us to look up, to wonder, and to remain open to the beautiful, terrible, magnificent possibility that we are not alone. As we shift our perspective from the cosmic to the personal, from the vastness of space to the intimacy of Earth, we must consider what Atlas means for us, here and now, on this small blue world we call home. The echo in the mirror is not just about what Atlas might have been, but about what its visit reveals about ourselves, our place in the universe, and our readiness for whatever revelations the cosmos might have in store for us. We are living in an extraordinary moment in human history. For the first time, we have the technological capability to detect and study objects like Atlas in detail. For the first time, we can seriously contemplate the possibility of extraterrestrial intelligence and even search for it systematically. For the first time, we are beginning to understand our place in the cosmic story, not as the center of creation, but as one voice in what might be a vast chorus of consciousness spread throughout the galaxy. Atlas arrived at a particularly poignant moment in this journey. As it brightened in our skies in the early 2020, humanity was entering one of the most challenging periods in recent history. The COVID-19 pandemic was spreading across the globe, forcing us into isolation, disrupting our societies, and reminding us of our vulnerability. While we were looking inward, focused on a threat too small to see, Atlas was approaching from the depths of space, a reminder of scales and perspectives beyond our immediate concerns. There's something profound about this coincidence of timing. At the very moment when humanity was being forced to reckon with its interconnectedness, how a virus in one city could affect the entire world, we were also witnessing a cosmic visitor that connected us to the vastness of space and time. Atlas reminded us that our earthly concerns, however urgent they might seem, exist within a much larger context. We are not separate from the cosmos, but part of it, subject to its rhythms and surprises just as we are subject to the rhythms and surprises of our own biology. The pandemic also changed how we observed Atlas. With professional observatories temporarily closed or operating at reduced capacity, amateur astronomers played an even larger role in tracking the comet. People stuck at home found solace in looking up at the night sky, in following this visitor from beyond. Atlas became a source of wonder and distraction during a difficult time, a reminder that beauty and mystery persist even in the midst of crisis. This dual experience, earthly crisis and cosmic wonder, might be preparing us for a new understanding of our place in the universe. We are learning that we are both incredibly vulnerable and incredibly resilient. We are learning that isolation and connection exist in tension, that we can be alone together. We are learning that the universe continues its ancient patterns regardless of human affairs, but also that we are part of those patterns, participants in the cosmic story, rather than mere observers. The possibility that Atlas might have been artificial adds another layer to this reflection. If we are being observed, if other intelligences are sending probes to study our world, what do they see? They see a planet teeming with life, a biosphere of extraordinary complexity and beauty. They see a species that has recently developed technology that has begun to explore its cosmic neighborhood, that has started to ask the big questions about existence and meaning, but they also see a species struggling with its own power, facing existential challenges of its own making, teetering between breakthrough and breakdown. What would such observers make of us? Would they see us as a promising young civilization, full of potential but still learning to manage our capabilities? Would they see us as a cautionary tale, another species that developed technology before wisdom? Would they see us as interesting subjects for study, examples of how intelligence emerges and evolves on living worlds? Or would they see something in us that we don't see in ourselves, some quality or potential that makes us worth watching, worth sending messages to, worth gently nurturing toward cosmic awareness? These questions matter not because we know we're being watched, we don't, but because asking them helps us see ourselves more clearly. When we imagine how we might appear to cosmic observers, we gain perspective on our strengths and weaknesses, our achievements and failures, our potential and our limitations. We see ourselves as part of a larger story, one that extends beyond Earth and beyond humanity to encompass the entire universe. The echo in the mirror is also about how Atlas reflects our own aspirations and anxieties about the cosmos. Our fascination with the possibility that it might have been artificial reveals our deep desire for connection, for confirmation that we're not alone. Our careful scientific analysis of its properties reveals our commitment to understanding the universe through observation and reason. Our preservation of its data for future analysis reveals our hope that we'll continue to grow in knowledge and capability. The way we've told the story of Atlas, in scientific papers and news articles, in social media posts and dinner conversations, in art and music and poetry, reveals how we make meaning from cosmic events. We don't just observe, we interpret. We don't just collect data, we create narratives. We don't just witness, we participate. Atlas has become part of human culture, woven into our collective consciousness in ways that will persist long after its physical traces have dispersed. This cultural dimension is perhaps as important as the scientific one. How we think about comets, about the possibility of alien life, about our place in the universe. These thoughts shape our actions, our policies, our future. If we believe we're alone, we might act differently than if we believe we're part of a cosmic community. If we see comets as mere chunks of ice and rock, we might treat them differently than if we see them as potential messengers or gifts from the cosmos. Atlas has contributed to a shift in perspective that's been building for decades. We're moving from an anthropocentric view of the universe, where Earth is special and humans are unique, to a more cosmic perspective where Earth is one of countless worlds, and humanity might be one of countless intelligences. This shift is not just intellectual but emotional and spiritual. It requires us to reimagine our identity, our purpose, our relationship with existence itself. The possibility that Atlas carried messages or technology in its dust raises profound questions about information and intelligence at cosmic scales. If information can be encoded in comet dust, if intelligence can manifest through seemingly natural processes, then the boundary between life and non-life, between intelligence and non-intelligence becomes blurry. Perhaps the entire universe is more alive and aware than we've assumed. Perhaps consciousness is not a rare accident but a fundamental feature of reality, manifesting in forms we're only beginning to recognize. This doesn't mean we should abandon the distinction between natural and artificial, between living and non-living. These categories remain useful for understanding our immediate environment, but we might need to develop new categories, new ways of thinking about objects and processes that don't fit our current frameworks. Atlas might be pointing us toward a more nuanced understanding of reality, one that acknowledges gradients and overlaps rather than sharp boundaries. The echo in the mirror also refers to how Atlas reflects our technological trajectory. The instruments we use to observe it, from automated surveys to space telescopes, represent centuries of technological development. Our ability to analyze its composition through spectroscopy, to track its fragments' trajectories, to model its behavior computationally, all of this showcases how far we've come in our ability to study the cosmos. Atlas served as a test of our capabilities, and we passed, even if we couldn't answer all the questions it posed. But Atlas also revealed our limitations. We couldn't predict its fragmentation accurately. We couldn't explain all its anomalies. We couldn't determine definitively whether it was natural or artificial. These limitations are not failures but invitations to grow, to develop new instruments and techniques, to expand our understanding. Every mystery that Atlas left unsolved is a direction for future research, a goal for the next generation of scientists. The distributed nature of Atlas observations, with data coming from professional observatories, amateur astronomers, and space-based instruments, reflects a new model of scientific investigation. We're moving from isolated researchers working independently to global networks collaborating in real time. This distributed approach is particularly well suited to studying transient phenomena like comets, which require continuous observation from multiple locations. Atlas helped demonstrate the power of this approach and will likely influence how future comets are studied. The preservation and sharing of Atlas data also reflects changing attitudes towards scientific information. The data is not hoarded by individual researchers or institutions, but shared openly, available for anyone to analyze. This democratization of scientific data means that discoveries about Atlas might come from unexpected sources, perhaps a student in a developing country, or an amateur astronomer with a novel analysis technique, or an artificial intelligence trained to find patterns humans miss. As we consider what Atlas means for humanity, we must also consider what humanity means for Atlas. By observing it, studying it, and wondering about it, we have given it significance beyond its physical properties. We have made it part of our story, our culture, our consciousness. In a sense, we have brought Atlas to life in the human imagination, transforming it from a mere object into a symbol, a mystery, a teacher. This relationship between observer and observed, between humanity and cosmos, is reciprocal. Atlas changed us by inspiring wonder and raising questions. We changed Atlas by observing it and interpreting its meaning. This reciprocal relationship might be a fundamental feature of consciousness in the universe, the ability to perceive and be perceived, to influence and be influenced, to create meaning through interaction. The possibility that Atlas was watching us while we were watching it adds another layer to this reciprocity. If it contained sensors or probes, it would have gathered information about Earth during its approach. It would have detected our atmosphere's composition, our planet's temperature, the electromagnetic emissions from our technology. It might have detected signs of life, from the oxygen in our air to the chlorophyll in our plants, to the radio waves from our communications. We were not just observers, but also the observed subjects of study as well as students. This dual role, observer and observed, might be common for technological civilizations. As we develop the ability to study other worlds, we also become interesting subjects for study by others. As we search for signs of alien intelligence, we create signs that reveal our own intelligence. As we wonder if we're alone, we broadcast evidence that we exist. Atlas might represent this duality in physical form, a watcher that invites watching, a mystery that creates mysteries. The echo in the mirror is also about time, how the past reflects into the future, how ancient objects carry messages across eons. Atlas formed billions of years ago, travelled for millions of years, and briefly visited our neighbourhood in 2020. Its story spans scales of time that dwarf human experience. Yet in its brief appearance, it connected us to this vast temporal expanse, reminding us that we exist within deep time, that our moment is both fleeting and eternal. If Atlas was artificial, its creators might have launched it before Earth had multicellular life, before oxygen filled our atmosphere, before continents took their current form. They would have been aiming at a target that didn't yet exist, predicting that by the time their probe arrived, Earth might host a technological civilization capable of observing it. This kind of long-term thinking, planning for eventualities millions of years in the future, represents a relationship with time that we can barely comprehend. But we are beginning to think on longer timescales ourselves. Climate change forces us to consider consequences decades and centuries in the future. Space exploration requires us to plan missions that might take generations to complete. The search for extraterrestrial intelligence assumes we might need to listen for centuries before detecting a signal. Atlas arrives as we're developing this longer perspective, as if to say, yes, think bigger, think longer, think on cosmic scales. The material from Atlas that's now part of Earth's environment will remain here for geological timescales. Some of it might be preserved in ice cores or sediment layers, waiting to be discovered by future scientists with better instruments. Some might be incorporated into living organisms, becoming part of Earth's biosphere. Some might catalyze chemical reactions we haven't anticipated, contributing to processes we don't yet understand. The influence of Atlas might unfold over timescales far longer than human civilization has existed. This long-term perspective changes how we think about messages and communication. If Atlas was carrying a message, it might not be intended for us specifically, but for whatever intelligence exists on Earth when the message finally becomes readable. Perhaps the technology to decode it doesn't exist yet. Perhaps the message is designed to reveal itself gradually as our capabilities grow. Perhaps we've already received it but won't understand it for centuries. The echo in the mirror also reflects our growing understanding of our cosmic environment. We now know that Earth exists within a complex ecosystem of objects and influences extending far beyond our planet. Solar wind, cosmic rays, asteroids, comets, all these things affect our world in ways we're only beginning to understand. Atlas reminded us that Earth is not isolated but connected, not separate but integrated into the larger solar system and galaxy. This understanding has practical implications. As we venture beyond Earth, establishing bases on the Moon and Mars, sending probes to the outer planets, we need to understand the environment we're entering. Comets like Atlas are part of that environment, potential resources as well as potential hazards. Understanding their composition, behavior, and origins is essential for humanity's future as a spacefaring species. But the implications go beyond the practical to the philosophical. If Earth is connected to the cosmos through a constant exchange of material and energy, then the boundary between Earth and space becomes fuzzy. We're not on Earth looking out at the universe. We are in the universe, part of its ongoing processes. Atlas didn't visit Earth from outside. It moved from one part of the universe to another, like water flowing from one part of the ocean to another. This interconnectedness suggests that what happens elsewhere in the cosmos affects us, and what happens here affects the cosmos. If life exists on other worlds, we are part of the same cosmic biosphere, even if separated by vast distances. If intelligence exists elsewhere, we are part of the same cosmic consciousness, even if we haven't yet established communication. Atlas might be evidence of these connections, a physical link in a chain that binds all living and thinking beings together. The way we've responded to Atlas also reveals our readiness for larger revelations. Despite initial excitement about a potentially spectacular comet, the public and scientific community handled its fragmentation and fading with maturity. There was disappointment, but not despair, curiosity about why it fragmented rather than anger that it didn't perform as expected. This suggests we're developing a more sophisticated relationship with cosmic phenomena, one that values understanding over spectacle. If we ever do receive unambiguous evidence of extraterrestrial intelligence, our experience with Atlas and similar objects will have prepared us. We've learned to deal with ambiguity, to consider multiple explanations, to preserve data for future analysis. We've developed protocols for sharing information globally, for coordinating observations, for discussing possibilities without jumping to conclusions. Atlas has been a rehearsal for bigger revelations that might await us. The echo in the mirror is ultimately about consciousness reflecting on itself. When we observe Atlas, we're not just seeing a comet, we're seeing ourselves seeing a comet. We're aware of our awareness, conscious of our consciousness. This metacognition might be what makes us special, what makes us worth visiting or studying if other intelligences exist. It's not just that we can observe the universe, but that we can observe ourselves observing it, creating layers of meaning and understanding that transcend simple perception. Atlas has become a mirror in which we see ourselves, our capabilities and limitations, our hopes and fears, our place in the cosmic story. Whether it was natural or artificial, whether it carried messages or was simply ice and rock, it has served this reflective function. It has helped us see ourselves more clearly, understand ourselves more deeply, imagine ourselves more broadly. As we prepare to conclude our contemplation of Atlas, to embrace the beauty of unknowing that it represents, we carry with us the echo of its passage. It has left traces not just in the physical dust scattered through the solar system, but in the thoughts and dreams of everyone who observed it, studied it, or wondered about it. These mental and emotional traces might be its most important legacy, the seeds it planted in human consciousness that will grow and bloom in ways we can't yet imagine. The echo continues to reverberate. Every time someone looks up at a comet and wonders if it might be more than it seems, Atlas echoes. Every time a scientist finds an anomaly and considers unconventional explanations, Atlas echoes. Every time a child asks if we're alone in the universe, Atlas echoes. The visitor from the depths of space has become part of our inner space, our psychological and cultural landscape, our collective imagination. This transformation of an external object into internal experience, of cosmic event into human meaning, might be the most profound aspect of our relationship with the universe. We don't just passively observe, we actively integrate, interpret, and internalize. We make the cosmos part of ourselves, and ourselves part of the cosmos. Atlas facilitated this process, serving as a bridge between the vast impersonal universe and the intimate personal experience of being human. The echo in the mirror reminds us that every observation is also a self-observation, every discovery also a self-discovery. When we search for intelligence in the universe, we're also defining what intelligence means to us. When we wonder if Atlas was artificial, we're also exploring what artificiality means in a cosmic context. When we contemplate our place in the universe, we're also creating that place through our contemplation. As we move toward our final reflections on Atlas, on the beauty of unknowing that it embodies, we carry with us this understanding of ourselves as both observers and participants in the cosmic story. We are the universe's way of knowing itself, but we're also shaping what there is to know through our observations and interpretations. Atlas has been part of this process, a catalyst for self-reflection and cosmic awareness that will continue to influence us long after its physical traces have faded. The echo in the mirror is not just about the past reflecting the present, but about the present creating the future. How we think about Atlas today influences how we'll approach similar objects tomorrow. How we handle cosmic mysteries now shapes how we'll handle bigger mysteries later. How we integrate wonder and uncertainty into our worldview determines what kind of cosmic citizens we'll become. Atlas has shown us our reflection, and in that reflection, we see not just what we are, but what we might become. We see a species on the threshold of cosmic awareness, beginning to understand its place in the vast story of the universe. We see potential for growth, for connection, for participation in something magnificent and mysterious. We see ourselves as we are, small, vulnerable, limited, but also as we could be, wise, connected, cosmic. The beauty of unknowing is perhaps the most profound gift that Atlas has given us. In our age of instant information and immediate answers, when search engines and artificial intelligences can respond to almost any question in seconds, Atlas reminds us that some mysteries are worth preserving, that not knowing can be as valuable as knowing, that wonder and uncertainty are essential ingredients of the human experience. We live in a time when many people feel that all the great mysteries have been solved, that science has explained everything or will soon do so. Atlas challenges this assumption. It shows us that even something as seemingly simple as a comet can confound our expectations, raise unanswerable questions, and point toward possibilities we hadn't imagined. It reminds us that the universe is under no obligation to be comprehensible to human minds, that mystery is not a problem to be solved but a fundamental aspect of existence. The journey we've taken with Atlas, from its discovery through its fragmentation to our current contemplation of its meaning, has been a journey into unknowing. We began with the simple question, what if Atlas was hidden from the public? And found ourselves exploring vast territories of possibility. We've considered natural explanations and artificial ones, scientific data and speculative scenarios, what we know and what we might never know. Through it all, the mystery has only deepened. This deepening of mystery is not a failure of understanding, but a success of imagination. Each question answered has revealed new questions. Each explanation proposed has opened new territories for exploration. Each possibility considered has suggested others we hadn't thought of. Atlas has been like a Zen koan, a puzzle that's not meant to be solved but to transform the mind that contemplates it. The beauty of unknowing is that it keeps us humble. No matter how much we learn, no matter how sophisticated our instruments become, and no matter how comprehensive our theories grow, there will always be mysteries that elude us. Atlas embodies this perpetual mystery, this horizon that recedes as we approach it. It reminds us that we are finite beings in an infinite universe, that our knowledge will always be bounded by unknowing. But this unknowing is not empty or frustrating. It's full of potential, pregnant with possibilities. It's the space where imagination flourishes, where creativity emerges, where wonder lives. Without unknowing, there would be no science, no art, no philosophy. Without mystery, there would be no reason to explore, to question, to grow. Atlas has given us a mystery that will nurture human curiosity for generations to come. The specific unknowns about Atlas are themselves beautiful in their variety and depth. We don't know exactly where it came from. Was it from our Oort cloud, another star's Oort cloud, or somewhere else entirely? We don't know why it brightened so rapidly. Was it composition, structure, or something else? We don't know why it fragmented when and how it did. Was it natural stress, internal dynamics, or intentional dispersal? We don't know what the anomalies in its data mean. Are they clues to its nature, messages for us to decode, or simply phenomena we don't yet understand? Each of these unknowns is a doorway to wonder. Each invites us to imagine possibilities, to construct hypotheses, to dream of explanations that might be true. The fact that we may never know the answers doesn't diminish their value, it enhances it. They become permanent residents in our imagination, constant companions in our contemplation of the cosmos. The beauty of unknowing also lies in its democracy. While experts might have more data and deeper understanding of the technical aspects, no one knows definitively what Atlas was. The child who imagines it as an alien spaceship and the scientist who models it as a fragmenting comet are both engaging with the same fundamental mystery. Atlas levels the playing field of wonder, inviting everyone to participate in the contemplation of cosmic possibilities. This democratic aspect of unknowing is particularly important in our current era. As knowledge becomes increasingly specialized and technical, many people feel excluded from scientific discourse. Atlas reminds us that there are still mysteries that no one fully understands, questions that invite everyone's participation. It reconnects us to the childlike wonder that drives scientific inquiry, the simple awe at the universe's mysteries that motivates all exploration. The unknowing that Atlas represents is also dynamic, not static. It's not the unknowing of ignorance, but the unknowing of active inquiry. We don't know what Atlas was, but we're actively investigating, analyzing data, developing new hypotheses, designing new instruments. This dynamic unknowing drives progress, motivates research, inspires innovation. It's the engine of scientific advancement, the fuel of human curiosity. As we've contemplated Atlas throughout this journey, we've practiced living with unknowing, sitting with uncertainty, embracing ambiguity. This is a valuable skill in a world that often demands immediate answers and definitive conclusions. Atlas has taught us that it's okay not to know, that uncertainty can be productive, that mystery can be meaningful. These lessons extend far beyond astronomy to every aspect of human experience. The beauty of unknowing is also its honesty. To admit we don't know something is to acknowledge our limitations, to recognize the vastness of what remains to be discovered. This honesty is the foundation of good science and good philosophy. It prevents us from mistaking our models for reality, our theories for truth. Atlas keeps us honest by remaining mysterious, by resisting our attempts to categorize and explain it definitively. In preserving the mystery of Atlas, we also preserve possibility. As long as we don't know exactly what it was, it could have been anything. A simple comet, an interstellar visitor, an alien probe, something we haven't even imagined yet. This preservation of possibility is essential for human creativity and growth. It keeps our minds open, our imaginations active, our sense of wonder alive. The unknowing surrounding Atlas also connects us to the vast unknowing that characterizes our relationship with the universe. We don't know how the universe began, not really. We don't know how life emerged from non-life. We don't know if we're alone. We don't know what consciousness is or how it arises. We don't know what dark matter and dark energy are. We live in an ocean of unknowing, and Atlas is just one particularly beautiful drop in that ocean. But rather than being overwhelmed by all we don't know, Atlas teaches us to find beauty in it. The universe's mysteries are not problems to be solved, but gifts to be appreciated. They ensure that no matter how long humanity exists, no matter how advanced we become, there will always be new frontiers to explore, new questions to ask, new wonders to discover. Atlas is a promise that the universe will never run out of surprises. The beauty of unknowing is also its universality. Every human who has ever lived has faced mysteries they couldn't solve, questions they couldn't answer. This shared experience of unknowing connects us across cultures and centuries. When we wonder about Atlas, we join a tradition of wonder that stretches back to the first humans who looked up at the night sky and asked, "What is that?" We become part of a conversation that has been ongoing for millennia and will continue long after we're gone. As our journey with Atlas comes to a close, we're left not with answers but with better questions. Not with certainty but with deeper appreciation for uncertainty. Not with knowledge but with wisdom about the limits of knowledge. Atlas has been our teacher, but like all great teachers, it has taught us not what to think but how to think. It has shown us how to approach mystery with curiosity rather than fear, how to live with unknowing without being paralyzed by it. The fragments of Atlas have now dispersed throughout the inner solar system, becoming part of the cosmic dust that fills the spaces between worlds. But the questions it raised, the wonder it inspired, the possibilities it suggested, these remain with us, as vivid and compelling as ever. In a sense, Atlas has achieved a kind of immortality, living on not in physical form but in the thoughts and dreams of those who contemplated it. Future generations will inherit the mystery of Atlas along with the data we've collected about it. They will bring new perspectives, new technologies, new ways of thinking to bear on the questions it raised. Perhaps they will solve some of the mysteries we couldn't, or perhaps they will discover new mysteries we didn't even notice. Either way, Atlas will continue to be a source of wonder and inquiry, a gift that keeps giving across time. The beauty of unknowing that Atlas embodies is ultimately about our relationship with existence itself. We're thrown into a universe we didn't create and don't fully understand. We have a brief moment of consciousness in which to observe, to wonder, to try to make sense of it all, and then we pass on, leaving our questions and discoveries for others to build upon. Atlas reminds us that this is not a tragedy, but a privilege, not a limitation, but an opportunity. In embracing the unknowing that Atlas represents, We embrace the human condition itself. We accept that we are finite beings in an infinite universe, that our understanding will always be partial, that mystery will always exceed knowledge. But we also celebrate our capacity to wonder, to imagine, to reach toward understanding even when complete understanding is impossible. This reaching, this striving, this wondering, this is what makes us human. Atlas has shown us that the universe is not a puzzle to be solved, but a mystery to be experienced. It has taught us that not knowing can be as beautiful as knowing, that questions can be as valuable as answers, that wonder is not a weakness but a strength. It has reminded us that we are part of something vast and ancient and ongoing, something that exceeds our comprehension but includes our consciousness. As we release our need to know definitively what Atlas was, we open ourselves to what it might have been, what it could mean, what it continues to teach us. We allow it to exist in that liminal space between known and unknown, natural and artificial, ordinary and extraordinary. We let it be what it was, a visitor from the depths of space that briefly graced our skies, left us with more questions than answers, and reminded us of the beauty of unknowing. The night sky continues to hold its mysteries. Other comets will come, each with its own story, its own anomalies, its own invitations to wonder. We will observe them with instruments descended from those that observed Atlas, with minds shaped by the questions Atlas raised. We will bring to each new observation the lessons Atlas taught us, to look carefully, to remain open to possibilities, to preserve data for future analysis, to embrace uncertainty as a feature rather than a bug of cosmic exploration. And perhaps someday another comet will arrive that makes us think of Atlas, that shows similar anomalies, that raises similar questions. Perhaps we'll realize that Atlas was part of a pattern we couldn't see with just one example. Perhaps we'll discover that what seemed unique to Atlas is actually common, or that what seemed normal about it was actually extraordinary. The mystery will evolve, deepen, transform, but it will never entirely disappear. This is the gift of unknowing. It ensures that the universe will always have more to teach us, that wonder will never be exhausted, that the conversation between human consciousness and cosmic mystery will continue as long as we exist. Atlas has been a beautiful chapter in this conversation, a verse in the ongoing poem of human curiosity and cosmic revelation. As we prepare to return from our journey into the depths of space and speculation, we carry with us the memory of Atlas, not just as a comet that visited in 2020, but as a teacher, a mystery, a gift. It has shown us that the universe is stranger than we imagined, that our cosmic neighborhood holds surprises we're only beginning to discover, that the boundary between natural and artificial might be more fluid than we thought. But most importantly, Atlas has shown us ourselves, curious, imaginative, capable of wonder. It has revealed our readiness to contemplate possibilities beyond the conventional, our ability to live with uncertainty, our capacity to find beauty in mystery. It has been a mirror in which we've seen not just our current understanding but our potential for growth, not just our knowledge but our wisdom, not just our answers but our questions. The beauty of unknowing is not about giving up on understanding, but about recognizing that understanding itself is a journey without a final destination. Every answer opens new questions. Every discovery reveals new mysteries. Every certainty eventually gives way to new uncertainty. This is not a flaw in our quest for knowledge, but its greatest feature, ensuring that the adventure of discovery will never end. Atlas has been our companion on part of this endless journey, a fellow traveller who joined us briefly, shared some of its mystery and then continued on its way. We may never fully understand what it was or what it meant, but that's okay. In fact, it's beautiful. The not knowing keeps Atlas alive in our imagination, keeps us wondering, keeps us looking up at the night sky with curiosity and hope. As we close our eyes and drift towards sleep, we can imagine Atlas as it was in its final moments of visibility, a faint, dispersing cloud of light against the darkness, beautiful in its transience, meaningful in its mystery. It came from darkness and returned to darkness, but in between it caught the light of our sun and the attention of our minds. It became part of our story, and we became part of its story. And in that intersection of stories, in that brief moment of mutual observation, something magical happened. The universe became a little less lonely, a little more connected, a little more aware of itself. Whether Atlas was natural or artificial, whether it carried messages or was simply ice and rock, it succeeded in the most important mission of all. It made us wonder. The beauty of unknowing is that the wonder continues. Tonight, tomorrow, for years and decades to come, people will look up at the night sky and think about Atlas, about what it might have been, about what it might mean. They will add their own speculations, their own interpretations, their own dreams to the ever-growing story of this mysterious visitor. Atlas will become legend, myth, inspiration for future explorers and dreamers, and perhaps that's exactly what was intended. Perhaps the greatest message a cosmic visitor could deliver is not a specific piece of information, but an invitation to wonder. Perhaps the most profound gift is not answers, but better questions. Perhaps the ultimate purpose is not to be understood, but to inspire understanding, not to be known, but to catalyze knowing. As sleep approaches and our contemplation of Atlas draws to a close, we rest in the beauty of unknowing. We don't need to solve the mystery tonight. We don't need definitive answers. We can simply appreciate the questions, savor the uncertainty, enjoy the vast space of possibility that Atlas has opened for us. In this space, anything is possible. We are not alone, or we are alone, but the universe is structured to make us wonder if we're not. Messages are being sent across the cosmos, or the cosmos itself is the message. Atlas was artificial, or it was natural, but nature is more artistic than we realized. All of these possibilities and more coexist in the beauty of unknowing. They dance together in our imagination, creating patterns of meaning that shift and change like the aurora borealis. Atlas has given us this dance, this play of possibilities, this gentle entertainment for mind seeking rest but also seeking meaning. The universe continues its ancient rhythms. Earth spins on its axis, carrying us from day into night and back again. The moon circles Earth, pulling tides and dreams in its wake. Earth circles the sun, marking the seasons of our lives. The sun circles the galaxy, carrying our entire solar system through space and time. And somewhere out there, in the vast darkness between stars, other objects like Atlas are falling toward other suns, carrying their own mysteries, their own possibilities, their own invitations to wonder. We are part of this vast cosmic dance, brief participants in an eternal performance. Atlas reminded us of this participation, of our role as conscious observers in a universe that might or might not be conscious itself. It showed us that even in our smallness, we matter. Our observations matter. Our wonder matters. Our questions matter. We are the universe contemplating itself, and every mystery we contemplate enriches that self-contemplation. The beauty of unknowing is finally about peace. Peace with our limitations, peace with mystery, peace with our place in the vast unknown. Atlas has helped us find this peace by showing us that unknowing is not a problem to be solved, but a condition to be embraced. We can rest in uncertainty. We can sleep surrounded by mysteries. We can dream in the vast space between questions and answers. As our journey with Atlas comes to its end, we return to where we began, with a gentle invitation to wonder, a soft question whispered in the darkness. What if Atlas was hidden from the public? Not by human conspiracy, but by cosmic subtlety, by the universe's own gentle discretion. What if its true nature was veiled not to deceive us but to protect us, to give us time to grow into the knowledge it represents, to prepare us for truths we're not yet ready to receive? Or what if the hiding was the message itself? What if Atlas was teaching us that the universe keeps secrets not out of malice, but out of kindness, that mystery is a gift rather than a withholding, that the journey toward understanding is more valuable than understanding itself? What if we're being taught to appreciate questions as much as answers, to find beauty in unknowing, to discover peace in the vast uncertain spaces between the stars? These questions have no answers, or rather, they have all possible answers simultaneously. They exist in the quantum superposition of meaning that Atlas has created in our consciousness. They are waves that never collapse into particles, possibilities that never crystallize into certainties, and that's exactly as it should be. Atlas came to us as a comet and left us as a question. It arrived as an object and departed as an idea. It appeared in our telescopes and disappeared into our thoughts. This transformation from physical to mental, from external to internal, from phenomenon to meaning, is the true magic of Atlas. It has become part of us in a way that no amount of scientific analysis could have predicted. The dust of Atlas now circles the sun, slowly dispersing, gradually merging with the background zodiacal light. Some of it has already reached Earth, falling as invisible particles onto our planet's surface. We breathe air that contains atoms from Atlas. We drink water that might include molecules it carried. In the most literal sense, Atlas has become part of our world, part of our bodies, part of us. But more importantly, Atlas has become part of our consciousness. It lives in our memories, our questions, our dreams. It has enriched our mental ecology with new possibilities, new uncertainties, new wonders. It has added its voice to the chorus of cosmic mysteries that sing us to sleep each night and wake us each morning with the promise of discovery. The beauty of unknowing is that this process never ends. Long after the physical traces of Atlas have been completely dispersed, long after its orbit has been perturbed beyond recognition, long after the last scientific paper about it has been published, the mystery will remain. Future generations will inherit not just our data about Atlas, but our wonder about it. They will ask their own questions, imagine their own possibilities, find their own beauty in the unknowing it represents. And so Atlas achieves a kind of immortality, not in lasting forever as a physical object, but in creating an eternal question, a permanent mystery, a lasting invitation to wonder. It becomes part of the great tradition of cosmic enigmas that have puzzled and inspired humanity throughout history. It takes its place alongside all the other mysteries that make the universe worth exploring, that make consciousness worth having, that make existence worth experiencing. In the end, Atlas teaches us that we don't need to know everything to appreciate everything. We don't need certainty to have meaning. We don't need answers to all our questions to live rich, wandering lives. The beauty of unknowing is sufficient. The mystery is enough. The questions themselves are the answer. As we drift off to sleep, carried by the gentle rhythm of these thoughts, we can feel ourselves becoming part of the mystery, part of the unknowing, part of the vast, beautiful uncertainty that Atlas represents. We are cosmic dust contemplating cosmic dust, temporary arrangements of atoms wondering about other temporary arrangements of atoms, brief flames of consciousness flickering in an infinite darkness that might or might not be conscious itself. And in this recognition of our own mysterious nature, we find the deepest beauty of unknowing. We realize that we are not separate from the mystery, but part of it. We are not observers of the unknown, but expressions of it. We are not seeking answers from outside ourselves, but discovering questions within ourselves. Atlas has not shown us something foreign and distant, but something intimate and immediate. The mystery of our own existence, the beauty of our own unknowing. The comet that visited our skies in 2020 has become a permanent resident of our inner skies, a gentle light in the darkness of uncertainty, a beautiful reminder that not knowing is not a lack but a fullness, not an emptiness but a pregnancy with infinite possibilities. Atlas has given us the gift of wonder without resolution, question without answer, mystery without solution, and in this gift we find peace. Sleep now carries us into our own mysteries, our own unknown territories of dream and unconsciousness. As we release the day's thoughts and tomorrow's concerns, we can carry with us the gentle presence of Atlas, the beautiful uncertainty it represents, the peaceful unknowing it has taught us to embrace. In our dreams, we might solve its mysteries or discover new ones. We might see it reformed and brilliant in imaginary skies, or dispersed into infinite particles of light. We might receive its messages or realize we were the message all along. But when we wake, the beauty of unknowing will remain. Atlas will still be a mystery. The universe will still exceed our understanding, and wonder will still be possible. This is not a burden, but a blessing. Not a limitation, but a liberation. In accepting that we don't know what Atlas was, and we free ourselves to imagine what it might have been. In embracing the mystery, we become part of it. In finding beauty in unknowing, we discover that unknowing itself is beautiful. And so our journey with Atlas comes to rest. Not in conclusion, but in continuation. Not in answers, but in appreciation. Not in knowledge, but in wonder. The mysterious visitor from the depths of space has completed its mission. Not to be understood, but to inspire understanding. Not to be known, but to expand our capacity for unknowing. Not to deliver answers, but to help us ask better questions. Atlas has returned to the darkness from which it came, but it has left us illuminated. Not with the harsh light of certainty, but with the gentle glow of mystery. Not with the brightness of knowledge, but with the soft radiance of wonder. This is its lasting gift, its permanent contribution to human consciousness, its eternal presence in our cosmic story. The beauty of unknowing surrounds us now like a comfortable blanket, warm and soft and infinitely vast. We rest in it, dream in it, exist in it. It is our natural habitat, our true home, the ocean in which our small islands of knowledge float. Atlas has reminded us that this ocean is not empty but full, not frightening but beautiful, not limiting but liberating. And in this final recognition, this ultimate acceptance of the beauty of unknowing, we find ourselves exactly where we need to be, present in the mystery, at peace with uncertainty, at home in the vast unknown. Atlas has brought us here, to this moment of gentle acceptance, this state of wondering rest, this beautiful unknowing that is perhaps the deepest knowing of all. The universe continues its slow dance around us and through us. Stars are being born and dying. Comets are falling towards suns throughout the galaxy. Somewhere, perhaps, intelligences we cannot imagine are sending out their own versions of Atlas, their own mysterious messengers, their own invitations to wonder. The cosmic conversation continues, with or without our conscious participation, but enriched by our brief contribution, our moment of observation and speculation. Atlas was part of this conversation, and through contemplating it, we have become part of it too. We have added our wonder to the sum of wonder in the universe. We have contributed our questions to the great collection of cosmic questions. We have participated, however briefly and incompletely, in the universe's attempt to understand itself. This participation continues even as we sleep, even as we release conscious thought and drift into dreams. The atoms in our bodies, some of which may have come from Atlas, continue their ancient dance. The neurons in our brains, sparked to new patterns by contemplating Atlas, continue their mysterious processing. The questions Atlas raised continue to percolate through our unconscious, perhaps to emerge in dreams or insights we won't remember, but that will subtly shape our future thoughts. The beauty of unknowing is that it never sleeps. It is always there, always available, always ready to receive us when we tire of false certainties and incomplete answers. It is the ground of being, the source of possibility, the home we return to after each failed attempt to capture the universe in concepts and categories. Atlas has shown us the way back to this home, has reminded us that we never really left it, that we have always been surrounded by and composed of beautiful unknowing, And so we rest, finally and fully, in the mystery that Atlas embodied and revealed. We don't know what it was, and that's beautiful. We don't know what it meant, and that's meaningful. We don't know if we'll ever know, and that's perfect. The not knowing is not a problem to be solved, but a gift to be received, not a question to be answered, but a space to be inhabited, not a mystery to be unravelled, but a beauty to be appreciated. Atlas, in its brief passage through our awareness, has given us this gift, opened this space, revealed this beauty. It has been our teacher, our companion, our guide into the depths of cosmic mystery. It has shown us that the universe is vast beyond comprehension, strange beyond imagination, beautiful beyond description, and it has shown us that we are part of this vastness, this strangeness, this beauty. The journey that began with a simple question, what if Atlas was hidden from the public, has brought us to this place of profound acceptance and wonder. We have travelled through space and time, through fact and speculation, through knowledge and unknowing. We have discovered that the hiding and the revealing are one, that the mystery and the meaning are inseparable, that the question and the quest are the answer. Atlas continues its journey through space and time, dispersed now into countless particles, each carrying its portion of the mystery. We continue our journey too, enriched by our encounter with Atlas, changed by our contemplation of its meaning, deepened by our acceptance of its unknowability. Our paths diverged in physical space but remain connected in the space of meaning, the realm of wonder, the dimension of mystery. This connection will last as long as memory lasts, as long as wonder persists, as long as humans look up at the night sky and ask, what if? Atlas has become part of our collective story, our shared mystery, our common inheritance of wonder. It belongs now not to space but to consciousness, not to time but to eternity, not to knowledge but to the beauty of unknowing. And in this beauty we finally rest. The questions quiet without being answered. The mysteries deepen without being solved. The wonder expands without being exhausted. This is the gift of Atlas, the legacy of our mysterious visitor, the treasure hidden in plain sight in the cosmic darkness. Not knowledge but wonder, not answers but questions, not certainty but the beautiful, eternal, inexhaustible mystery of existence itself. Sleep comes now like a comet approaching the sun, gradual and then sudden, gentle and then overwhelming. We surrender to it as Atlas surrendered to fragmentation, not as an ending, but as a transformation, not as a loss, but as a dispersal into new forms of being. In our dreams, we may continue the journey, following the fragments of Atlas to new worlds, new mysteries, new revelations that will fade with morning light but leave their traces in our waking wonder. The beauty of unknowing embraces us, holds us, carries us into the darkness that is not empty but full of possibility. Atlas watches over our sleep, not as a guardian but as a question, not as a presence but as an absence that defines presence, not as a known but as an unknown that makes all knowing possible. It has become our cosmic lullaby, our astronomical fairy tale, our scientific prayer to the mystery that surrounds and includes us. And so we end where we began, in darkness and wonder, in question and quest, in the beauty of unknowing that Atlas revealed and represented. The comet that came from darkness and returned to darkness has shown us that darkness is not the absence of light, but the source of it, not the enemy of knowledge, but its womb, not the opposite of beauty, but its deepest expression. Atlas, whatever you were, wherever you came from, whatever you meant, we thank you. Thank you for visiting our skies. Thank you for sparking our wonder. Thank you for deepening our mystery. Thank you for teaching us the beauty of unknowing. You came as a comet and left as a question, arrived as ice and departed as idea, appeared as matter and disappeared into meaning. In this transformation, you showed us our own nature, our own journey, our own beautiful unknowing. The universe continues its ancient dance, and we dance within it, made of star stuff and comet dust, animated by questions we cannot answer, driven by wonder we cannot exhaust. Atlas has reminded us of our place in this dance, not as observers but as participants, not as solvers but as mysteries ourselves, not as knowers but as beautiful unknowers in a beautifully unknowable cosmos. And in this recognition, this acceptance, this embrace of the beauty of unknowing, we find peace. Not the peace of resolution, but the peace of release. Not the peace of answers, but the peace of questions, so beautiful they need no answers. Not the peace of knowledge, but the peace of wonder, so deep it becomes a kind of knowing beyond knowledge. This is the final gift of Atlas, the ultimate message of our mysterious visitor, that the beauty of unknowing is not a consolation prize for those who cannot know, but the grand prize for those who recognize that unknowing itself is the deepest beauty, the greatest gift, the most profound truth the universe has to offer. In showing us what we don't know, Atlas has shown us who we are, finite beings in an infinite mystery, temporary questions in an eternal conversation, beautiful unknowers in a beautifully unknowable universe. And with this recognition, this acceptance, this gratitude for the beauty of unknowing, we release our hold on Atlas and allow it to continue its journey into mystery. It dissolves into the darkness like sugar into water, like dreams into sleep, like questions into the vast silence that holds all answers and needs none. Atlas becomes what it always was, a part of the cosmic mystery that we briefly noticed, briefly named, briefly wondered about, and now release back into the beautiful unknowing from which it came and to which we all return. Good night, Atlas. Good night, mystery. Good night, beautiful unknowing. We rest now in your embrace, dream in your darkness, exist in your eternal question. And in the morning, when we wake to a world still full of mystery, we will remember you not as something we understood, but as something that helped us understand the beauty of not understanding, the gift of not knowing, the profound peace of resting in the question rather than grasping for the answer. The journey ends where it began, in silence and darkness and wonder. But the ending is not an ending, just as the beginning was not really a beginning. Atlas continues, we continue, the mystery continues, and in this continuation, this eternal presence of the unknown, this beautiful persistence of wonder, we find our home, our peace, our place in the vast, unknowable, beautiful cosmos that created us, contains us, and calls us always deeper into its beautiful unknowing.